Okay, there we go. Hello, hello. You can hear me now, right? All right. Let's see if we can get this working here. So, I think we should just try and go to evaluate pipeline. I think that once we've got everything set up here, yeah, we need to do things. So something wrong with my OBS. It doesn't show. The status of the stream. Okay, there we go. All right, there we go. All right. So we've got a pipeline. We set up a bunch of streams, and I think now we could try just to like read and write to them. So I think what we want to do is basically, I want to do like a loop. So I'm gonna loop through all the things, read and writers. Let's do the pointer just in case. And then we're gonna read from the reader and write into the next one. Actually, let's do that, and it's like if I is less than length Okay, let's do this first, because I think we have two scenarios, basically, or maybe three. But basically, the first item we're gonna read from, and not write anything into. So basically, you will take whatever we read from this reader. Actually, hang on. Yeah. So this reader is reading from the stream. So we should use the reader and not the stream next, I think. Yeah, so basically we could actually do like stream or reader.stream, or even use the thing that I already had, like the forward stream reader. And then the writer is going to be the next thing. So that's going to be the next RV next. It's going to be I+1. And that's why we need this check to guard against like the last one. So we don't want to do this the last item, but we do this now. You are the writer dot writer. I think we need to do this anyway. Maybe... Or is it already... No, because we still need to like... We still need to forward the actual data. Maybe we'll do this in like, we'll capture this thing in a loop. But the thing is that we don't have like, we don't know. Yeah, I think what we need to do, we need to set up the streams in such a way that they are like very generic. We don't know if there's from a process or if it's from a function or whatever. Each stream is just gonna try and encapsulate whatever is going on underneath. So if we have a file writer, we can surround that. And basically, yeah, we can use the IO reader stream, perhaps. And the source here is a reader, and then the stream will try to read from the stream and do that. So that can use... No, well, yeah. What about the reader writer stream? The thing is, we need something to actively write into the writer, which is what we're doing with this loop over here. Let's also have RV closed. It's going to be a boolean of this length, I think. And we're going to initialize it to false. And I guess if we're closed, we don't really need to do it, but if we're closed, this is gonna be end of stream anyway, so, well, let's just do this. If we're not closed, we'll do it. We'll forward the stream. So what this will do, basically, well, for the first stream, it's gonna read from the source somehow. What did we set up the readers to actually be? Right. So it's like the standard in is this reader here, but then we need to like loop through here and actually read from it. So I don't think we actually needed to create the contexts. We just needed to set up all the reader writers. Like the context would only have mattered if we actually set up threads to run the stuff anyway. But here we're kind of doing it in like a blocking manner. Okay, well, whatever. Yeah. So reading from the first one, which one is that? It's this. No, the first one is blocked. Or wait. No, it's... No, it's just a reader from the first thing, which should get pushed. Like, where do we set up the source? Okay, I guess now is the question, okay, well, how do we write into the reader, the first reader, I guess the idea was that, well, my idea was that we set up the context and then this would kind of set up reading, like streaming into those things. And that works for everything that is not a process, basically. Because processes right now don't stream in the thing because we need to wait for them. Or we need to have them basically run async. And so, like, if the first reader is like connected to the first, yeah, it's connected to the first, like, let's say echo whatever, that doesn't have a standard data. It's just gonna echo. It's just gonna produce data. So we could just read from it, right? The thing is, though, the processes themselves don't actually do anything like that. So I think what we need to do as well is that we need to look at the connections. But that is the pipes and not the streams. Okay, maybe we need some kind of underlying functionality for connecting streams as well, like implementation-based connections of the streams, and then you call a function to like pull things along the stream to the next thing, something like that. Because the thing is, we don't know here if we have a process or if we have something else. If we have something else, it's already gonna have the data in the reader. But if it's a process, we need to push the data from the standard out, from the process into the reader, and that has to happen, you know, in a loop, in this loop here. So basically, let's say we have RW. This needs to, well, we could read from it, but the data isn't there yet. If the source is a process, the data isn't there. So I think that what we need to do is we need to like encapsulate, or we actually what we could do is maybe wrap the reader writer in like the file writer thing. Yeah. Hang on. We need this reader. No wait, this is the interface of this reader. But we need like a source. The source is basically the writer at this point. But I guess we could set up. I guess we have to now set up a different stream. Like this is kind of weird how I did this. Maybe this doesn't really work with other streams. This is like turning a stream into with like the IO stuff. Yeah, this it's just to this whole thing is just to be able to have something to write into that we can also read from. That's all this is. And that it happens to have the stream interface on it, but that doesn't really do much at this point. Now this one is like we have a source, that's the reader, and that could be the standard out of the process, for example. And and then when we read from this one, it will actually read from that reader. So that will actually pull the data from like properly. So I think that when we set up the child process, we're gonna have to bring this along somewhere. Hello Dab Gaming. Spent over 5 hours debugging my empty React Tailwind website. Oh really? What was the issue? That sounds not fun, to be honest. I'm just gonna refill my coffee right back. All right. Had a post CSS config file, even though it's running right Tailwind CSS plugin. So because of post CSS config file, I got the same error for like 5 hours. Okay. Did you use like one of those scaffolding things, or did you install things yourself? Because I don't know if you actually need a post CSS config file. I don't remember ever having a post CSS config file, but I guess maybe you can set some stuff on it. And with Tailwind, I think you can just say like Tailwind init, and it will create a config for that if you need it. But those kind of errors, they are the worst. Like you're spending so much time and you're like, what the hell is going on? And then it's like some bullshit thing like that. That is, yeah, I feel you there. I've been there a couple of times, or many, many times. Okay, this goddamn stream. So basically, well, if we can get, so what do we need? What do we need from the streams? Do we need all of the streams to be like reader writers? Or connected, like connect them to outputs. And then you call that they will be like, it will be like a push-pull thing. Like, Because if you write to a writer, that could potentially also, like, if you let's say you implement a writer interface and you then have a drain, because yeah, a reader kind of implements a pulling interface, like you're pulling from something, while a writer implements a pushing interface. But then the stream could potentially have both. But then, and then you can, like, if you connect a bunch of streams, if you then pull, or if you push on like the first stream, it's gonna like try and push things along the whole thing. Except when you have this like child process in the way, because, well, it depends. I guess it depends on the stream interface. Yo, Penguin. What's up? Sorry, I have to BRB 1 second here. All right. How many total lines is your code right now? I don't know. That's a metric I usually don't really worry about. I worry about it if it's like in one file. When the file starts to get a little bit out of hand, that's a sign that, well, at least for me personally, I know that some people don't really care about the lines of code in a file either. But I just feel like, okay, well, once it hits, you know, over 1,000 or 2,000, 3,000, then it feels like, okay, well, it's time to kind of try to see if we can, you know, break it up or optimize, or like refactor, do some tidying up. Because usually it, you know, you have a bunch of duplicated code or something, and when it gets to those numbers, it's like, it feels like it's gonna get harder to maintain, harder to like read the code and reason about it and all that. So it's also, it's just the nicest feeling when you refactor something and you turn it from like 1,000 lines of code to like a couple of hundred or something, and it looks way nicer and everything. So like you're turning, like, basically, well, I guess you could say turning spaghetti code into like refined code, I guess you could say. I don't really, if like, I don't know, the project, I'm not sure actually, like I've never really measured the project lines of code. Is that something you could do? Like I think there's like a thing called lines or something. Or what is it? Oh, sorry. You could do something like this. That can't be right. Yeah, I don't know. You see my bad skills here? If I was using Runic, maybe I could figure it out. Oh, sorry, that was the... Okay, hang on. I was like, this is all the source code in Runic. Sorry. There we go. But a lot of this is also like AI slop that I just don't use anymore as well. So it's not even this much, like 24,000 here. So it's less than 24,000. When I started working, when was that? Yo, Penguin again. I don't remember actually when I started. I think I started in November, it looks like. So about a month now. Yeah, just almost exactly a month. Okay, I was gonna do some theory crafting here, so actually set it to Runic. So basically what we have is that, let's say we have like echo, blah blah, cat, whatever. Okay, this is like the I guess the MVP of what we want to have, and then to extend it you just add the same kind of thing in between here. But okay, so what's happening here is that we have some kind of source here, connecting that, so we're connecting that to a rider, which is then defined basically in here, the glue part. So if we expand this a little bit here, this would be a stream kind of thing of U8s, and this is getting like glued or standard out, is going into the stream, right? and standard in is closed. Let's just denote it like this. It's closed. Standard out is going into stream. And if we have some other source, it's going, so this is only for processes, but if we have some other source, that's just gonna write straight into the stream. Now, when we say connected here, it's not gonna output automatically into the stream, because we don't use like, I think POSIX, as I read, as I understand, could have a way of kind of connecting pipes automatically, so you don't have to kind of pull the data yourself and write it into the stream yourself. But basically this doesn't happen automatically, so we have to go through, basically the stream implementation is going to have to pull the data from whatever the standard out has for us here. So we have to read the data from that, I'm pretty sure. Like if we go to evaluator and we go to spawn process, for example, and then we have these standard out is a pipe, which makes it into a file, which we then can read from. And the process is gonna write to the standard out, and then we can read from the standard out. So we basically have to read this standard out manually. And in order to do that, we could bake it into, the idea that I have is to bake it into the stream implementation, right? So yeah, so we read from the stream, which will pull it from the child process, okay? And then the output goes into the next one. So then we should have the source for the next one. Then we can read from this stream, but then we have to also connect it to the next one. We have to, yeah. So I guess that could be also be the implementation of the stream. It's like we're reading from a process and then we're writing to another stream. And that stream is kind of like a, I guess, a writer stream that we can, or read writer stream, whatever, that we can push data into. And then this thing has to now connect to a standard in file. So I guess we need both like a file reader stream and a file writer stream thing. Horseshit 24k lines of code in a month. I don't really know if that's that much, but I mean the most of it is written by AI, so you have to keep that in mind. Like I went like day in, day out telling AI to, hey, I want this feature, hey, I want this feature. That was the start of this project. But then after a while, like the AI just couldn't work anymore. It like it gave up, and then I inspected the code and it was like a whole bunch of bullshit. And so that's why I took over, and now I do everything manually. So you have to keep that in mind. Like, yeah, the AI can spew out a whole bunch of code. So take it with a whole bunch of buckets of salt. And most of those lines of code I don't even use now, because the AI, it's a bunch of AI slop basically. Okay, but this one, so this one is an IO reader which reads from this file. So that's connected directly to the pipe. So when we read from that stream, it's gonna pull directly from standard out here. And then that needs to be connected to the next like file writer thing, which will write directly into the standard in of this one, and so on. So we need like a reader stream and a writer stream basically. We need like both the pull version and the push version here. And then even we might even want to have both, like the reader writer stream. I think what we want to do with that one is change it so that it becomes more generic, I guess. Like it could, the source stream, it could have a source stream that it reads from, a reader stream, and then a writer stream that it pushes into. Perhaps. And then when you like you try to pull from, yeah, and then we connect the whole pipe, and then you just have to pull from the last one. Ah, yeah, we could probably do something like that. Okay. Okay. The only thing is, no, well, yeah. Okay, let's just do reader stream. That will take a reader as a source. I mean, we already have it, actually. We have it here. We have the iReader byte stream. So it only works with bytes, you know. And yeah, it has a source, which is the reader. And I guess, yeah, this should already be implemented. It's just reading from the stream, and then we get the next thing here, right? Yeah. And now we need a version of this that is the writer stream. But before I will implement this, this will be the destination. This is a pushing stream now, so it's kind of weird. Maybe, I don't know. So it's like, okay, well, what happens? Or do we even, well, I guess we have to, since, okay, so if we're gonna pull from the end, that one, let's say it's reading from a file. But in turn, it's not really connected to the previous in the, why did I delete the thing? So this one goes like this into a stream. So standard out is this is a file that goes into, that is automatically written into the stream. Well, let's go from, well, no. Okay, yeah, so far so good. Yeah, so that part is done. And then we have like cat, let's say, cat again. And you will just go to the inherited writer for standard out. So that's fine. However, we do have here, well, okay. Will you go to the inherited, or, yeah, I think you will. I mean, we could also do like this, and this goes to the inherited like this. Like, it doesn't really matter. So then it's like, okay, so we pull from this one, which will read from whatever this has outputted. But if we need more, this doesn't have it. There's like a disconnection here. So we still need to like pull through the whole chain. But we could make it so that it's kind of encapsulated into the streams themselves, maybe. So this pulls from this, the standard out. If the standard out doesn't have anything, I mean, or is it a push actually? This is pushing there, so this should push into the next one. I think this is a push actually, because, well, let's say if we push, let's say this automatically pushes in here, so that's already done. But what about this? So now let's say you have a rider into standard in. Yeah, we can push all the way through, and then at the end you would get I mean, probably a buffer that we can read from. So we need like a buffer. But this pushes all the way through, and at the end or we can just connect it directly to the rider out, standard out, actually. So then what do we actually need to do then? I don't think we actually need to do anything, actually. We just need to set up all the streams, and then everything should be working automatically, actually. Okay, so we just have to figure out how we can make that pushing mechanism. So we have this reader-writer stream. So basically this is like its own thing. It's like it has a writer that you can write into, and then you can read from it as well using the reader interface. So it's basically just as a way of buffering. This is just a buffer basically. It's just a way to connect a writer to this buffered stream which you can then read from. So it's not really doing anything. It's not forwarding whatever we read into the next thing, which is what we need, I think. We need to, the first process is gonna push write data into here. So this stream will always get pushed data into. So then it's this stream's job to push data into the next one. So this could be a reader-writer stream, except we also have a destination. Like this is the writer for this, for writing into the buffer. But then we also need a destination, which is going to be the writer, some kind of writer that we write into. And then you can read from this, but we don't really need to have a reader actually here. We just need to have a writer that like forwards to some other destination, but we have some buffering in between, I guess. Do we even need that actually? I mean, this is the whole thing. Like this whole streaming interface might be moot. You know, it might end up being nothing, because we have the reader-writer interfaces. The only thing that I can think of is like the typed pipes, but you could potentially use the built-in reader-writers for that as well. You can write structs, you can read structs, you can write whatever zig type you have and read that as well. So yeah, but I'm just gonna do this to like see if we can get this if we can get this like working. And then once it's working, we could pull out the parts that's required and just go with that and try to like refine it like that. Because basically here is like all we have is a rider that the I mean, we have three things actually. We have the ref, which is like, you know, for us to be able to share this as a stable pointer without it being have a special container of something, and you can also, you know, ref it and release it when you're done, and we don't have to like manage it, the memory in more than having to like create refs and release them. But then the other thing we have is the rider, which we can use this as a buffer or simply forward it to the destination. So basically, like when we write to this rider, we should actually just write it to the destination immediately. To be honest, like we could just bypass this whole rider here and just write to the destination. But the problem is though, I guess there could be data coming in that we need to buffer before there's like a stabilization point, like when we spawn up the things and then they start processing, or we process, like we push things into here immediately. Maybe, I mean, we could also, how did we create these reader riders? Like we create them here, and then we could probably like connect them to each other, maybe. No, the thing is like we connect these as context here. Yeah, that's right. Okay. Yeah, so we actually need to have some kind of buffering thing, and then when we actually do have a place to push the data into, like maybe we don't have a destination at first, but then we connect this to a destination, and then it starts to funnel the data through. Yeah. So let's say that this is null, and we don't even need to have this as a reader actually. In that case, we just need the rider. It's just going to be a push action. Yeah. So then, yeah, we have connect. This is now actually not the rider. This is going to be the destination here. Yeah. And so basically also like once we've connected, we are going to try to write the buffer immediately out to, we're basically going to flush the rider, except we don't have a special drain function to forward it to this destination here. But what we could do is we could say destination we can say destination and then write all, and then the bytes are gonna be, well, let's get the parent like this. Parent rider. So now we have the allocating, and then we just do two on slice. So that will consume everything that is in the buffer immediately and write it all to the destination, and then it will because we have to write that first, and then once we are connected. Oh shit, okay, maybe we actually do need to implement the rider interface here. because it's still gonna use like this writer here to still write data into this. So it's not like connected automatically. So we have to, let's see. Okay, well, let's see if we can just make the writer interface actually. So basically I'm gonna have the buffer writer. That's gonna be the allocating writer. And then we're gonna have the actual writer, which is gonna be just a writer, and that's our interface. And we're not really gonna have a reader. The reader, I'm just gonna remove. Like, this is just gonna be a writer stream actually. So I'm gonna remove the reader. And we actually need now a writer vtable instead, which I think the only thing we need is drain. Perhaps. We'll see. Because drain is the thing that's responsible for forwarding whatever, like if the buffer is empty in the writer, it's gonna use the drain function to actually figure out where to push data into. And let's see, so this is gonna be vtable is writer vtable. Do we need anything else? Buffer is basically, I'm just gonna say it's empty. And so we need the drain function. Now if you read this, this is like drain here. This is not, doesn't have a default implementation. Send file copies contents from an open file to a logical sync. Has like, okay, you have like unimplemented. Consumes all remaining buffer. Yeah, the flush. So these have like default implementation. So we don't really, and since we have 0 buffer, we don't really care about these. Drain is the only thing we need to worry about. So sends bytes to the logical sync, which is gonna be the destination to whatever this stream is streaming to. A write will only be sent here if it could not fit into buffer or during a flush operation. This is consumed first, followed by each slice of data in order. Elements of data may alias each other, but may not alias buffer. This function modifies writer end, buffer, yeah. So a whole bunch of stuff. So basically, I mean, really what this is the streaming part. It doesn't really make sense here. Like this, the only thing we're using the stream for is basically to be able to say that this is a ref right now. We don't really need this to be, you know, a stream. Like, it doesn't really matter. We're not even going to use the streaming part for this. We're only interested in creating a special writer that will, while this is not connected, this is more like a connected writer. So basically, when this is not connected, it will, this writer will write into an allocating writer. So that will kind of buffer whatever is written into it. And you can use memory to allocate more things as it's needed. So we can basically store any amount of data, basically. And it's just so that we have a secure way of actually like keeping the data stored. And then once the destination has been connected, then we empty the buffer, and we also now funnel all data that's written in here, draining directly into the destination. That is what this is for. So I'm almost tempted to just remove the streaming part from this, just because it doesn't make sense anymore. Like we don't ever call next here. Like next doesn't really make sense. We're not supposed to even call this function. So I'm just gonna do I'm just gonna return completed, because yeah, whatever. I'm buffering the buffered buff writer. Yeah, the problem with this, like the writers does have a buffer. Like they have their own buffer. However, they are like, it's just a slice that is, you know, it's, you define it once and it has that, or well, it's a slice, so it's a pointer to something. But having this buffer here makes sure that we don't run out of, you know, space on the buffer. Okay, so the writer, let's see, this is going to be the buffer writer. And deinitialize, that's going to be buffer writer deinitialize. And yeah, there we go. Okay, so get allocator, yes. Now let's rename you to writer get parent. And we're not gonna do this. I do feel a little bit sad to remove all this, since we made a kind of a reader's thing for the streams, but I think that we're not really gonna use it, so that's the thing. And we're probably just gonna scrap this whole stream thing. I'm not sure actually, but what we're gonna actually, you know what? Let's keep it around just so we have the implementation somewhere, because I haven't committed it or anything. But we're gonna do like writer drain. And yeah, we'll figure out what this is doing here. So we need a writer, of course, the data and splat. And then this would be a IO writer error. All right. Oops. Now, like, I still don't really understand this part. So I'm just gonna read through this again, because I read through it once and I was like, what the hell is splat? What the hell is data? But let's see. Yeah, sends bytes to the logical sink. A write will only be sent here if it could not fit into buffer or during a flush operation. Yes, which will happen every time now because the buffer is like it's 0 length. Buffer is consumed first, followed by each slice of data in order. Yeah, we don't need to care about the buffer, of course. So we have to go through each slice of data. So we get like a bunch of chunks, I guess. Elements of data may alias each other, but may not alias buffer. This function modifies the writer and the writer buffer in an implementation defined manner. Right. Data length must be non-zero. Okay, well, buffer. Write a buffer in an implementation defined manner. Okay, so are you saying that we can use the buffer willy-nilly? Like, we can kind of use this pointer somehow? Like, let's say you have an array list. Could you have the buffer point to the items in the array list and then use that? And whenever it like invalidates the pointer, you have to reset the buffer pointer. Because that would also kind of maybe solve the problem. Anyway, let's just do it like we're doing it here. Data, like it might be possible to avoid using the allocating writer, but whatever. We could also just look at the allocating writer to see how that's implemented to maybe get the answer there, but whatever. And it's like we don't really have an end, I guess. So we're just gonna leave this part here, and a buffer. It's just gonna take whatever thing we have, we're just gonna funnel it. Yeah. Data length must be non-zero. The last element of data is repeated as necessary, so it's written splat number of times. Right. This is the part where it's weird. The last element of data is repeated as necessary, so that it's written splat number of times, which may be 0. So is that like an optimization thing? It's like, yeah, we have a bunch of zeros, so now we don't want to create a buffer that holds everything. We just have a number which just means repeat. Okay, so I think, yeah, this is gonna be important. We need to, I'm just gonna copy this. This function may not be called if the data to be written could have been stored in buffer instead, including when the amount of data written is 0 and buffer capacity is 0. Yeah, see, it has like logic there for the buffer. I don't really understand. Number of bytes consumed from data is returned, excluding bytes from buffer. Okay. Number of bytes returned may be 0, which does not indicate a stream end. The subsequent call may return non-zero or signal end of stream. So basically, if you return 0, since data always has to be, no, okay. So the array that gets sent in must have at least one item, but then the item could have 0 elements, I think. Where did I read that? I'm not sure. But okay. I mean, actually, we could just redirect this. Like, we could just say, like, if, well, get the parent. If why? Okay, destination. If we don't have a destination, if parent destination, well, if we have a destination, I guess. Why is this not? Why does this not work? Oh, it's a reader. Wait. Oh wait. Okay. Okay. I'm stupid. This should be writer get parent. Writer get parent. It's just that the LSP is like you always have to wrestle with it. Okay. Yeah. Still, we don't get this type here. What's happening? Oh, it does not. Okay, it doesn't like this. Okay, well, I guess we don't really care about this then. We guess we have two writers to. It's basically like a switch. We have either we funnel the thing into one of the writers or we funnel it to the other writer. So basically, if we have a destination, we will drain. Can't we just call the drain function? When this function is called, it usually means the buffer got full, so time to return an error. Or wait, no, we just write the things, right? But then we have to kind of, okay, let's do like destination equals to parent destination or else the buffer writer. So that is now the destination, right? I wish there was a way to kind of do this operation. Maybe there is actually. Maybe we can say something like write. Is there like this kind of thing? Write splat. There we go. There we go. That should basically never, like, yeah, we should just do that. There we go. Easy peasy. And then I guess send file, we could also implement those because it's kind of the same thing actually. We're just selecting which writer it goes to. Send fail. Flush. Yeah, let's just do like this should be very easy implementation of all of these actually. So this is like send file. What do you need? Okay, you need a file reader and a limit. And there could be a file error now. Wait. Get splattered. Writer send file, yes. So now we get the thing and we get the thing. We could just make a convenience function for this. Writer get destination. Self. When we get the destination out. Return writer get parent. Self. Destination or else, well, okay, let's send file. Now, can we just send file? Yeah, we just call this, right? That just forwards it. Okay. Now we need flush. Actually, let's copy this. Wait, what is default flash actually? Okay, well, same thing here. Because flush exists. You only need the writer. Okay, and now I need rebase. Void. Yeah, we just do this again. Rebase, preserve, capacity. There we go. Easy peasy. We just select destination writer and write it. The base, yeah. Okay, so now we have a writer stream instead of what we had before. So now, right, so before we did this reader writer stream, but this doesn't exist anymore. It's going to be a readers or writer stream, I mean. Okay, so we have the writer stream for all of these stages. Maybe we just need one less. I'm not sure. There might be a one-off here. We just initialize them using the allocator, and we're deinitializing them at the end. We're freeing them up. Now, the last stream. Let's see. I think most of this should be kind of the same. Okay, so standard in. All right, see you later, Penguin. Good luck. Okay. Now we're back here. Okay, so basically, okay, standard in for the first one is blocked, right? We don't have standard in there. Next one, it's gonna be the previous. Oh shit. We need to write into. We need to write into the previous. 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 We need to w a file. Wait. Actually, you know what? The thing is here, like, standard in doesn't really work here, because what we need is something to push data, not pull. So we can't really set up these as readers. That's the issue here. Maybe I'll just ignore this one for now, and we'll just set these streams up to kind of, yeah, their destination should be set up. I mean, we could actually just, I mean, yeah. Wait, no, actually, hang on. So this will connect into standard in here, right? Which will push into, so this is a writer stream now. So you will push there into, yeah, the writer, yes. Then we need to connect this writer. It's gonna be the writer into standard in of this cat. That's gonna be a writer, not a reader. The standard in is a writer, not a reader. Okay. Okay. I think, yeah, I think if we just make this into a writer. And then, okay, let's say we have this as a writer. Then we're connecting the first stream into the next streams. No, wait, into this. So when we spawn something that requires standard in, it's gonna, no, but how do we get the writer? That's the thing. We need like a callback to kind of connect the writer. Actually, that would mean that standard in should be like a writer stream. Yeah, okay. So these should actually be writer streams. So then when we spawn this, it's gonna take that writer stream, connect it to the standard in of cat. Standard out is gonna connect, or it's not gonna connect. Well, it's gonna wait. What is standard out gonna be? How will it be pull data from standard out? Actually, that is a good question. This doesn't happen. This does not happen automatically. Like, this is getting put into the file. We need to stream the file into here somewhere. I don't think, yeah, that's not gonna happen automatically. I don't know why I said that. We need to actually have a reader writer stream that connects the output here into, no, but yeah, into a source reader. No, a writer, I mean. No, yeah, but that's the writer stream itself. It just writes to the writer stream's own interface, and then the destination is going to be the standard in of this. This is going to get connected to the writer of this stream, which the destination is then okay. We already have everything. Okay. But we do need to change these into being the writer streams and not the writers. Well, I guess we could just take the rider. No, yeah, because it's already implemented in the interface. We just need to. Yeah, that's what we. Okay, actually, we don't need to connect. Well, okay. The standard in here. No, the standard in actually needs to be connected. Yeah, that needs to be connected. So actually, this needs to be this, I think. So that we can, so that when the process spawns, it can grab the rider's stream, connect standard in to that. Yeah. I mean, it's either going to be a rider stream or some kind of function or callback, something that actually connects, something that is like connectable or something. Yeah. That we need to have that. Okay. And then these could just be the riders because let's say we get standard out here. No, wait. We still need to connect the writer of this file out into here. Yeah, that doesn't happen automatically. I don't know. Like the actual streaming part does not happen automatically. Because this is stuck in some kind of file. And then we have to create a reader from the file, standard out, and actually actively read from that. I was kind of thinking that, okay, but maybe we could like, what if we pull from here? That would kind of pull through the whole chain. But it's like we pull from here. It's gonna read from standard out here. But then we're stuck again. So then we need some kind of bridge to here, which will kind of also pull from here. We need to like pull from everything here. I was thinking like maybe we could implement this automatically in the whole pipeline, but maybe we actually have to kind of call forward this reader into the writer here. Or could we solve it with a reader-writer stream? Something needs to actively pull from the reader and push it into the writer. That's the problem. And then the same issue comes here. This will push to standard in here. However, the standard out will not push automatically into, because we need to pull that data. Unless we can. Could we implement some kind of reader interface that will do that? No, because you need to pull the data. You need to call it. Okay. So next idea then maybe is to set up, like each time you create a process, we still do this connection here, but this one needs to be stored in like some kind of, maybe the context or something. It will be stored in like this operation that we need to do here needs to be stored somewhere so that we can loop through all of those, and so that they will funnel the data through. That's my idea right now. So then each step here will be saved as like some kind of, you know, forwarding action from the reader to the writer. And then we would just loop through all of those during while we're like processing the entire pipeline. We're going to loop through all of the current stream forwarding things and forward them in here. So could we have this information here? So this would automatically, no, it wouldn't automatically connect. It would, you would try to, well, we could connect the reader. We could make this into a reader-writer stream. However, you need to like actually actively call reader. So if we make it into a reader-writer stream, we will connect out into the reader as well. So that would now also be like connected. And then we call like dot stream or something, or dot forward on it, and it will actually pull data, push it through. So we just have to loop through each of these. Yeah. We loop through each of these, pull data, or do forward in action on each of them. That should work, hopefully. Okay, let's try that. So let's actually make this now into a reader stream. However, the reader is not an interface now. It's gonna be a source, which also may not exist. And we'll change you to connect destination. And then we'll also do, whoops, connect source. Yeah. So we're connecting the source. Now when we connect the source, do we wanna immediately try and read from it? Nah. However, when we connect the destination, we should empty the writer. Like we should empty the, actually this is the buffer writer. We should empty the buffer writer because it's not gonna get used anymore. Once it's connected, we just empty it immediately and then we're done. With that one. But the source, we don't really need to read from it. We can do that later. Okay. So let's add a function that is gonna be like forward. And we're basically gonna do self reader or source is self source or else return. Destination. Well, actually, yeah, we can get the destination. Let's have this function actually. So then self is this instead. We don't want to get the parent, we just do self. And then you will be like return get parent self. No. rider get get destination. All right. So we get the destination. We have the rider. That we should always have a destination. It's either the buffered rider or the connected one. But source may not exist. So if we don't have a source, forward is not going to do anything. Once we have a source, we will call stream into the destination. And I guess you could include a limit here if you want. And then, yeah, this will return like how many bytes were streamed, which we don't really care about, to be honest. And if there's an error, we can look at the error, because I think it's gonna be nice if we can see that, yeah, we have been completed. Actually, let's do like a bool here. Returns true if stream has ended, or if source is completed. So if the error is reader stream error end of stream, then we return true. Else we return some other error, because this could be like a streaming error. All right. Otherwise we return false down here. Right. So this is gonna forward the reader to the writer. Okay. And we're using the built-in stream function on reader to push things forward. This is a really cool function to stream data from a reader to a writer with some limit there. And you can check the end of stream here. Okay. So now, let's see. So now it's up to the process to connect to like the reader or the standard out is going to connect to this reader writer stream, and then standard in is going to connect to this the writer here is going to connect to the standard in of the next one. And so, and then we call stream or forward on all of these to forward the things through. Okay. Now, did we rename this again? Reader writer stream, yes. So we rename this again. Yet again. Okay. Good, good, good. All right. And then the standard in needs to be something that we can connect to. Same thing with standard out, maybe, actually, to be honest. I mean, why not? Wait, how's that gonna... Yeah, it's just gonna connect its... standard out. Yeah, the idea is here is that the process will connect its standard out to this standard out. How is that gonna happen? It actually needs to connect standard out to something that is connectable. How does it do that? We still need to have a callback type thing. So basically, maybe we'll like make this more make another interface that could connect that. But I think actually what we do is we just provide the actual reader-writer stream that it should be able to connect to. So that's that. And so now the index is supposed to be kind of the glue in between. So this would be index 0. So standard in is blocked. No, wait. Yeah, it's blocked here. Yeah, I guess it's... No, yeah, it's blocked. I thought about... no, it's standard out is index 0, yes. Which is there, standard out. No, it's there, yeah. But this is +1 now. Wait. No, this one. Standard is blocked. This goes into RW list index +1. It should just be index, I think. No, because this is the last, right? We're doing last to first. Right. So we're over here, that's right. When index is 0, we're over here. And we do need this glue here to be able to continuously pull things through. So this, actually, we need as many reader-writer streams as we have stages here. 1, 2, 3, 1, 2, 3. They're all connected on the end. And the last one is connected to standard out. So actually, we could connect that directly here. The last one, which we actually don't need a separate thing for. We don't actually need a last thing. We actually, well, we'll just do like the last, like this. And then we connect. Wait, what? Oh. These are the interface functions. There we go. Okay, so we connect the destination to be standard out inherited. Although, okay, well, actually now that we changed the pipes to be connectable, to all the pipes are reader-writers now. So actually we don't even need this last one. This is already a reader-writer stream. Well, that kind of changes the whole dynamic here. That changes like... Yeah, so this one doesn't even need to be here. In that case. So actually then you can be like -1. Hang on. Well, okay. So we need to change this a little bit. So you don't really have an IO type. I mean, we could do a union enum, I guess, to support multiple things here. No, that would be so much stuff. Actually, I think this will be like a... I don't think this will be a pointer actually, but I think we need to have it as a ref. Probably. Which is the ref type? The ref is this, right? So actually, yeah, we need this type here. Or do we? No, I think the way we did this is that when you make a new ref, you just need, well, how do you release the ref? Well, you call stream initializer. Yeah, that's right. That is correct. Yeah. Okay, so then we actually can share a pointer, but we just have, yeah. It's a little bit weird. Like this pattern I didn't have before, but now I have it for some reason. Where did we go? Yeah, so we have a pointer to a read or write stream. And we'll just do this. And this. And this. And this. Yeah. All right. Actually, whatever. Let's just do this. We don't need. I don't think we need connections now either. Yeah, because it's all gonna be connected. It's all gonna be. We all gonna know. Yeah. There's just so many changes now that it's like, okay, well, if this doesn't work out, and we have to go back, it's gonna be. Okay, well, let's do pipe reader materialized into pipe materialized. Okay. Now I just want to double check how this is done here. We're getting the forward context, right? This. I mean, I guess that's fine. It's a pointer, so yeah, that's fine. And this is already a pointer, so that's this. So this doesn't, well. And then we have like this connect thing, which we don't need. Close is closed. Forget about it. And the streaming mode doesn't really make sense now, actually. You know what? What if we flush the thing? Like, let's say the destination is the allocating, and we flush it. That's gonna just make the data disappear, right? So we actually never flush the we might flush the destination here, maybe? Or do we actually do that? I don't think we do. We just need to flush. Like, the only time we flush is basically if we are writing to a file descriptor. And so we don't really know if we should flush here or not. If we flush, if it's like a buffered, it's just gonna discard everything. Yo, Nandu, what's up? Okay, let's forget about that for now. Because I know there's like this streaming mode is determining if you're gonna flash or not at some point. I'm just gonna leave it as it is right now. And yeah, that's that. So now we have to we set up this stuff here. We will take, well, that's the inherited one. I'm not even sure if we need this one. Well, we do need to connect it, I guess. Wait, do we need more than one connection, more than one source actually? That's gonna be strange. Maybe we actually have to have a thread in that case, because we don't know when data is coming in. Or I guess it could be like if they appear at the same time, there's just, we just loop through. Sure, that's gonna be, yeah, okay, it's not really a problem. Alright, good, great. I'm doing fine. I'm just trying to figure this out here. I've been wrestling with this issue for a while. But I feel like we're getting to a close here soon. I always have that feeling, and then something else pops up. But I think we might be close now. Hello, Cyphos. This is all about me, but I still enjoy it. Just to start learning to see how would this read. I mean, yeah, if you're just started learning, I mean, have you programmed before, or is C your first language? Because if it's your first, then it's no surprise that it would be, you know, confusing. Well, this would be confusing for anyone. Let me say that first of all. Since I wrote this code here, and it's like, yeah, right now it's like a lot of testing and experimenting here. Okay. No, it's always gonna be like if you have several. Well, you can have background processes. I guess background processes will be able to. But actually, if you have a reader-writer, you could just create another reader-writer to connect to that reader. No, you can't. Yes, you can, actually, because you connect the writer from the source. You connect the source reader writer. That writer is gonna connect into the reader here, so that should be fine. Yeah. Wait, not the reader. No, the writer is gonna connect directly to the writer. Yeah. It's just gonna be writing directly into the writer. Yeah. Okay. So we're good there. Okay. Cool. Now, what now? Okay, let's see what's happening over at spawn process. Right. So here's the forward context. So these should now be a bunch of reader writers that we can use to connect. So I see first. Okay, yeah. How long have you studied C? Have you done any, tried to start doing any projects or anything? Also, why did you choose C? It's an interesting question to me. It's not a jab or anything, it's just, I'm just curious what the reason was. Because it could be anything, it could be like, you know, if you want to learn like embedded programming or just low level, I don't know, become a Linux developer, a Linux kernel developer. Okay, here we're doing like connection stuff. So instead of doing this, because this doesn't exist anymore, we don't have connect. We are doing the stream. So standard in. We need to connect. Wait, but we don't always have this. Isn't this an optional? Hang on. Okay, these need to be optional, right? There we go. No, not they. Not them. This needs to be optional. There we go. So then why is this a thing? It should be like stream. Which programming language are you good at? I mean, I would say like the most experience I have is with TypeScript, probably. Yeah, I mean, I've been using TypeScript since I first started web development professionally, so 10 years. professionally. And other than that, I mean, I've been dabbling in a lot of different languages, but yeah, TypeScript is I guess TypeScript and then C#. I've been also have some experience through work as well. So I guess those two are probably, you know, I'm gonna say I'm proficient in those two. So if we have standard in, now this standard in is going to be whatever standard in is gonna be before. So basically for this cat, it's gonna be this one standard in here, which means we need to connect this rider, which is the destination, to child standard in. Which should exist at this point, because we are checking should we just say, actually, what the hell? Should we just say like .stream here? This doesn't make sense. Yeah, there we go. Right. So if we have standard in, we have the stream, we connect standard in to the standard in, yeah, we connect the destination of this rider into standard in of this cat. So yeah, okay. So you're supposed to have this diagram so that we can kind of see what we're doing here, because my mind is just, when we're talking about these pipelines and going in and out and which is which, I just get lost. So this diagram is really helpful here. Okay, so standard out of this one gets connected to the standard, like, or it gets connected to the reader of this one. So we need to connect a source. We need to read from standard out, and the source is child standard out. And actually we need the reader. Oh, scheiße. We need to actually create these readers and keep them somewhere, actually. Okay. All right, I'll just BRB 1 second here. Okay. Well, I mean, one thing we could do, which will kind of make this less generic, is we could change the source destination to file descriptors instead. And then you could store the things in here, like the file reader, file writer, everything in here. But yeah, that makes it way less generic. But I guess it will solve our problem a little bit. However, we don't always have our file reader and writer. We could just have something that outputs into a reader, like yeah, or I mean a writer. So that doesn't really work. We could maybe make them into... No. I was thinking maybe we could make an arena for the whole pipeline, and when the pipeline is done, we just release everything. Maybe. I'm not sure, because, yeah, as I said multiple times before, like, I've always ran into issues when trying to nest arenas. So that doesn't really speak to me that much. Honestly, I don't have anything concrete planned yet. I'm using C to build understanding. Starting with many small progress exercise until like memory points. Yeah, I understand. But what is your, like, why did you choose C of all, like what made you choose C? There has to be some specific reason. Like, what, did you just pick a random programming language to start with, or like what's the why C? It's just an interesting first interesting choice. Or like, is your goal to learn like low-level programming? Because I mean, I guess C is pretty good for that in that case. Although Zig also works, because that's also low level. And it could be easier to start with because of like more modern tooling and stuff like that. I don't know. I actually don't know, because I don't use C, so I just know that C is old, and yeah, I haven't really tried to do anything modern things in C, but yeah. But there are, I mean, I'm not saying like C is unusable. Like, there are a lot of people using C right now, so it's not really, that's not what I'm saying. I'm saying, like, if you're learning something new, maybe it's easier to I mean, I guess it depends what your goal is, but yeah, I don't know. I guess I'm just curious why you choose C. Like, what's the reason? Like, did you, when you started to learn about, or did you knew maybe you wanted to learn programming, but how did you choose C? Like, was it just the first language you picked, or? I feel like C is building the engine, everything else drives the car. Well, that's not really true. I mean, SIG is just as low level as C. And so is like C++ and a lot of other languages as well. But you know, you're right in that the higher level languages, it's not as close to like the actual computer, you could say, like the hardware of the computer, you could say. It's not like we're programming directly with the hardware, because you have an operating system in between as well. So you're not like interfacing directly with the hardware components, but you are, you know, it is lower level, but a lot of things are quote unquote like virtualized. Like you have virtual memory nowadays with the memory addresses are not like the actual physical addresses of the RAM, for example. They are like virtual, and you get your own like virtual space, and that's mostly, I think, for like security and stuff like that. So yeah, I okay, I don't know why I'm talking about this, but I'm just trying to give you a little bit more perspective, I guess. I'm just trying to say like C is not the like be all end all of low level programming languages. I guess that's what I'm trying to say. There are other alternatives, like Zig, for example. Now, but I think that once you've like chosen C, you can start with that. That's fine, you know, and then you can try other things as well. So it's like, and then you can like build up, you know. I mean, usually it's a good idea to learn a bunch of different programming languages, because you get more perspective and you learn more things. But for you, that's all like starting out. That's probably not where you're at right now. You should probably focus on C and continue with that. If you feel like that is, you know, where your interests lie right now, then you should stick with that. And once you've gotten some more meat on your bones there, then you can start, you know, looking at other things. Yeah. So because it's just gonna get confusing otherwise. I think it's like it's hard enough to learn one like starting out learning programming. Nandu, I must have been a similar spot. Started learning C as my second programming language to prepare for learning Zig. I found Zig's documentation confusing, so I think learning a low-level language will make it easier to pick up Zig. My first language was Python. Yeah. I mean, yeah, okay, that's another thing. Like Zig, maybe it's not a good choice for a first language. I will say that because of the fact that it's a new language. The documentation is lacking in a lot of areas. There's not much support out there on like Stack Overflow or Google or whatever. So you're not going to get much help. It's like right now it's I guess it mainly for programmers that want to explore a new language that doesn't need a lot of help, I guess. Like if you're starting to learn programming, you should have like to get the most out of it, I guess. Make it less frustrating. It's good to have good resources, and yeah, it's a good point. I would suggest not picking Zig as your actual first programming language. Maybe your first low-level language, maybe. But I think going from C to Zig is probably easier than going from Python to Zig, just because of the fact that you stated there, Nando, with the documentation, and you know, you have to learn about stuff like pointers and you know, manual memory management and all that. But once you have learned it, then you can jump to Zig. I'm just trying to recruit Zig people here. Join the cult. I can see things in your Zig, so I thought it was interesting. Yeah, there's a lot of information on C. Yeah, so I mean, Zig and C does have a lot of things in common. I mean, they are both manual memory management. you know, we both have pointers. Like this is a pointer here. This is a pointer. This is also optional here. But this star is the same. It's just a pointer. And also in Zig, it kind of means that it's mutable. And here you have like also like addressing or referencing or whatever you want to call it. So it's the same syntax a little bit. Same but different. Learning pointers now in arrays, right? Yeah. It can get complicated very quickly. I think it's also like the limitation of the mind. Like when I started out, it's also, you know, you have to just doing this as well. Like the mind has to wrap around what is happening. Like the mind has to understand what is happening, and that is like the most difficult thing, I think. And you can get frustrated when you're like trying to do something and you just don't. It just doesn't wrap around. Yeah, C can also be compiled by Zig, so yeah, that's true. Safeguards, you mean these? It's kind of like, well, I guess in C there's no such thing as null, but there is like the null pointer. But isn't that just 0, defined to be 0 or something? But this is like an actual optional type, like it's built into the type here. So it's like nothing else can be null. Only optional things can be set to null, and it doesn't have to be a pointer. It can be any type. And then there's like, you know, things in the there's features in the language that makes you. Yeah, it's basically a safeguard, as you say, to handle null, like optional values. It can be null or it can be something else. And then you have to check as well if it's null or not. Well, not really like void, but well, I mean, okay, void is kind of like, as the thing is, null actually is like a value that you can check against. Void, you can't really check against void. Void is basically nothing. It's like 0 bytes. You don't really check against. But null is an actual value that's like stored in Zig, which has a specific value that you can check against. So then you would know if something is null or not. And so the optional type is basically, yeah, we're guarding against if something is kind of like populated or not. Or that's how you can use it anyway. Okay, hang on. So where were we? Sorry, I'm just trying to get back a little bit. Okay, let's go through this again. So here, this one's gonna connect standard in as a writer that this is gonna connect its destination to. So that we connect destination of this stream to the writer of standard in on cat. And then the next one, the standard out of cat, is gonna connect to the reader of the next thing. So that's the source. And then standard is the same thing. So that will also connect to the source of standard Okay. Oh yeah. So, okay, so the problem is that this is just a file, and we need to create a file reader in order to read from this. So this, we need, because this expects a writer, or a writer here in this case. This expects a writer, and these expect readers. Whoops. And so this writer, but the problem is that we can't just create it locally here. We need to actually have something that we keep around, and then it's like, where is that handled, and when does it get like deallocated? That's the question now. How do we handle the lifetime of these readers and writers? I guess potentially, like, we could just do it in the pipeline, I guess. So we could probably just use like the allocator. Well, it's gonna be like self.allocator actually. Maybe we'll do it in the scope. Maybe the scope could have some kind of allocation thing. We could like allocate some special things on there that will get popped off. Yeah, okay, sure. All right, let's try and support that. So the thing is, we do have like these single frames, which can hold bindings to values that can be basically anything. But I think we can have something that is like an allocating frame or something. That could be cool. Okay, let's just add that. So let's add like an allocating. So basically this is like an arena, or maybe an arena maybe. Let's just try it. But what if you have a nested arena? I think we'll just make our own thing. Let's do an allocating frame. So yeah, so basically, yeah, we need an I guess we need an allocator. And then we need to know, we need to keep track of all the pointers. Actually, we need their size as well. So should it just be a bunch of slices maybe? Yeah, and then we just use this to get the thing. So, and then we have like init. which we'll just go through. Pointers, or free pointer, and that. All right. Now, let's add a function here that is gonna be like alloc, which will get the current allocating frame, which we're gonna use to allocate stuff. So we're allocating some kind of type, and we need scope stack. Actually, does this need to be first? Always, I think so. Yeah, so we have the type, and I guess also, no, so yeah, because alloc means some kind of number as well. So how many? And then this would be like allocator error, or a slice of t's. And so we will get the allocating frame. Wait, didn't we have this get? Oh, there we go. Current single frame. That gives us that. And you will be frame is get, no, current allocating frame. Okay, I guess this is an error. There we go. So we get the frame, and then we will say allocating, allocator, allocate. However, this is now in bytes, so we actually have to allocate a bunch of bytes. Or, no, actually, no. We'll allocate this as usual. Okay, and this is the allocated, which we then will return. But now we need to keep track of the thing, so we need to say pointers append, and we'll use the same allocator, of course. And then the item, now this needs to be some kind of value. Whoops. Value as bytes. As bytes. 2 bytes. Wait, in terms of copy? What do you mean? What's the difference between 2 bytes and as bytes? Okay, I guess we'll use as bytes because we want to have the, I guess, yeah, all the information that we need. Like the pointer should have all the things it should have. I guess this would be, maybe be, well, maybe this is not gonna be correct. Maybe we do need 2 bytes because we do need that type there, the U8 type. Although this would be an array, actually. Now that doesn't work. Wait. Given a pointer to a single item returns a slice of the bytes, right? That's not really what we need. What did you do? To give it any value returns a copy of its bytes in an array. Yeah, the slice doesn't really have the slice is just a slice, so that's not gonna work. We need to kind of map. We need to kind of slice as bytes. Given a slice returns a slice to the underlying bytes. Blah blah blah. Yeah, I think this is what we need. Also, what are you? Okay, so you're a. Yeah, you should be a slice. Always here. Okay, yeah. So then the value is allocated. And I guess we also need an defer here. All right. Can you return an error? No. All right, so that's alloc, and I guess we also need like create. Or do we? Yeah, I guess we do. And you will get a pointer to T. How long have I been writing code? Well, yeah, I started learning 30 years ago when I was young, and I've been working professionally for 10 years. And every time I say that, I feel very old. Right, so this does that, and then we create. But this time we need to do destroy, and here we need to do not slice as bytes, but just as bytes, I think. Given a pointer to a single item returns an I, a slice of underlying bytes. There we go. I think that's what we need. Alright, so now we have these. Now, I'm just gonna assume we never really want to destroy things in the scope, so I'm just gonna not implement those. But now we have alloc and create. So, yeah, now we can create a context around the pipeline, which can help us allocate things. And so then it's basically fire and forget. We just allocate things into the context. When the context gets popped, it will automatically deallocate everything. All right. Now we do need an allocator in our first, because we need one here. So I'm just gonna push an allocating here. And we need like, well, do we have an allocator actually? Yeah, we have an allocator here, so we can just use that. So we need to push allocating, but we don't have that function, so I'm gonna create it here. Push allocating, which doesn't need any input, and you would be allocating yes, which we can also change this to be like a a tag name, but whatever. So then this would be like init allocating, which we don't have as well. And we don't need to try that. No. There we go. And you don't need these things. Is it because you're a ref? Yeah, I think, yeah. Alright, cool. Wish I decided to learn 20 years ago. Better late than never. Yeah, that's better late than never. I was just really lucky, I guess. I had my older brother who was part of a game development team. I mean, just a couple of friends, you know, trying to do some stuff. But I'm not really sure how they got into it. But one of his friends was like somehow had learned programming for some reason, and they made some games. And I just looked at the source code and I was like, hey, I'm gonna try this. I'm gonna try making something. It was like, I looked at C++ in Windows Notepad and tried to do stuff with it, with that. You can imagine how far I got with that. But yeah, I would say right now it's like, well, you have like plenty more resources to learn. And it's so much easier to learn now than it was back then. But yeah. Where am I? What am I doing here? Allocating, yeah. So, okay. Now we go back. So now we should have allocating context that we can use. So, and then, actually, yeah, now it should work here, yes. But now we added one scope, so we should pop. Actually, we only pop one frame here. I mean, it doesn't really matter because we should pop everything actually, because we're like after this the whole scope gets deinitialized anyway, so we don't really need to pop a bunch of scopes here. But I guess we can if we want. Like 1, 2, 3, 4. Is that it? Okay. Yeah, because the deinitialize is gonna go ahead and go in and deinitialize everything anyway. So, but yeah. Okay. Where are we? We need to go to the evaluator. All right. So now we actually can create these in the current context, except we need to also create the actual context. So we need to go to evaluate pipeline. No. We need to go evaluate pipeline. And we need to push. Basically, we could push right here. Scopes, push allocating. So we'll push that context, and we can. Normally, I would want to like have defer, but the pop is also try. Maybe we should change pop to not be try. Okay. Well, anyway, and then down here we're gonna do scopes pop frame. And that should be that, because otherwise we're pushing a frame here and then we're popping it directly, because that's the forwarding to these. Yeah, and when this gets deinitialized, we're not really like closing these or anything. It's gonna be like detached. And then here it's also, we don't, well, wait, wasn't the thing that we should pop? Yeah, okay, we are pushing. Oh yeah, so every evaluation gets their own forwarding frame. That's right. Yeah, that should be fine. Okay. Yeah, so everything that happens in here, if anything is using the allocating frame, it will get initialized over here. Which is fine, because the pipeline needs to be, it's gonna block until everything is done. Anyway, if we wanted this to be like asynchronous, we couldn't pop this here. We have to like detach the whole scope and have it running in a separate thing. But we don't really have that right now, so I'm not even gonna worry about that. So now we'll go to evaluate, or actually, yeah, spawn process here. Now we have a, now we actually have an allocating thing that we can use. So let's create a what is it we want to create? I think we want to create like a file reader. That's right. Or file writer. Yeah. So this is gonna be a file writer. So this is the standard in writer. Okay. And then we need, well, I guess we only do it if we actually connect it, to be honest. So let's have like an if here. Whoa, what kind of color is this? What happened there? I feel like I'm in a dream. Okay, there we go. So that's the writer. Or, well, that's the pointer to the writer. Now we have to populate it with child standard in. Dot writer, that's right. Streaming, I guess, will do. And no buffer. So then this basically means no buffer. So now that I know basically about the inner workings of the reader-writer interfaces, I kind of know what this buffer is used for now. If you don't have a buffer here, it's just going to drain everything out, which means that there could be issues here. There could be issues at this point. Maybe. Maybe not. Maybe it will. Is the act of creating a writer gonna be doing something? I'm not sure. Because this is like the operating system is supposed to forward the thing, I guess, maybe. Okay, well, anyway. We'll create a writer into standard. No, wait, that's standard in. Right, yeah. We're in control here. So standard in writer there. That's the file writer, yes. Okay, and then this destination is going to be the standard in writer dot interface, and there we go. So now we've connected the standard in writer to the destination of this stream. So when this stream is forwarding stuff, it's going to forward things into this standard in, which is the child standard in. Okay. Now let's just do the same for these. So here, but here we need a reader. because we're reading from standard out of the process. And you're going to be reader streaming, and you're going to be standard out now, and you are standard in reader interface. Okay. Wait, standard in reader, standard out reader. And same thing here, except out is All right. Okay. So now, when we call, so now standard out here is connected to the source of this part. So the source is connected to the standard out here. Then the next one is going to have its destination. This destination is going to connect to the writer of this. And when we call forward on this stream, it's going to read from this file descriptor and then write out to, it's going to stream that to standard in file here. And then it's just repeated throughout. And now the only thing we need to do is set up these correctly. And also forward them. But we don't use this thing anymore, I don't think. We'll figure it out. Let's do... Okay, so now let's figure out what's happening here. So first index, that means this is blocked, which makes sense. Standard in is blocked. It shouldn't accept any standard in. Standard out is the reader. It should be the first reader. So this should be like index, because index now is 0. That's the first reader. Or reader writer. So we're connecting that. The standard out of this is going to connect to the source of this one. Okay. And then the next thing, we have cat. Now, this is larger than 0, so we are not blocked on standard in anymore. We're actually connecting now the standard out of this, which is the destination of this one, into standard in here. So this should be -1, which is correct. So we're connecting the destination of this to the standard in of this. Okay, that seems correct. And then the next, and the standard out is gonna connect to, now index is 1, so this is the next reader writer stream. Yeah, so that should be correct. And then let's also look at the last item here, which means that this one is still correct. Now I is equal to 0 because we start at the end here. And that means that we connect to the last stream, which in this case is actually going to be the inherited standard out. So we don't have last RW, we have standard out inherited, which is already, these are already, actually we don't need this to be, wait, do they need to be a pointer actually? Hang on. We have to change this here. Writer info. Materialized. You no longer have like a reader. You have a stream. So this should be this is the stream, which is a reader writer stream. There we go. And then this is the stream. All right. So you take a pointer to a stream. That should be this pointer, yes. And you are already a point. Wait, you are pipe materialized. So you should be this. But that should exist. I mean, I guess if this doesn't exist, what happens then? We don't have, like, pipe out is, like, standard out is blocked. I mean, it's just gonna be, we just don't connect it, I guess. Okay. Now, this should all be set up properly, hopefully. And we get the next frame set up. This is gonna execute it in that frame and all that stuff. And it's all gonna connect. And then, okay, let's say that all is done. Do we need to keep track of this? Okay, what's gonna happen here? So I think the only thing we need to do is call forward stream on all of these reader writers. Is it forward or stream? Is forward, right? Yeah. Forward, I guess unlimited. Which returns true if it's closed. So we just do forward until it's closed, and then we set that to be closed, and then we don't forward that one anymore. And then we do it for everything else. And we'll see what kind of issues will crop up here. Because I will assume that you're not going to get some disconnection issues like in the middle here. Like as long as you still, the standard in is still open from echo, this shouldn't close the standard in. It should, and then it closes when, I guess this one closes the file descriptor. And that gets closed. And do we actually need to terminate echo at that point? I'm not sure actually. We need to also wait for these processes somehow, which we can do. I mean, we have the child processor stored in a list, which we can loop through, and we can call wait on them. Although we need to know which ones we need to wait for though. Actually, maybe we actually need to store this child process ID somewhere to be able to know which one we should close here or wait for here. Maybe that could be another context. That could be another context. I'm abusing the context system, it feels like. But yeah, that could be another context, actually. Yeah, okay. There could be another easier way to do it, but that's just an idea that popped into my mind right now. So let's do it. Do it. So this would be like, I guess, like, what would this be? Like a process context or something. Child process context. So it's basically like when you pop this context, we have to wait for all of these child process to end. Yeah. All right. Good luck. Have a nice day. See you later. Okay, so we'll just keep them in. I mean, we could just keep them in a child. How large? How big is this? Okay, it's a sizable. Yeah, it's a lot of things actually. So maybe we should create a pointer. I mean, well, we could just keep them in a list actually. Let's do like children or processes. A bunch of processes here. We will, or do we even need to store the whole child? I mean, could we like get the child from ID or something? Maybe not. I don't know. Because when you call, like let's say you call wait that needs a child, what is it using from self? Terminated. Okay, sure. Okay, let's do this. Let's say we have a child process. Okay, it just came to me here. So we store the child processes here. We will initialize. We don't need an allocator. Okay, deinitialize will, now deinitialize will actually wait for them. So we will go through all of our processes. And doesn't this need to be a pointer? Items. So this will be a child process, and we will wait for this. What kind of error do you have? Spawn error. Get process info memory error. Okay. I guess we'll try that. Maybe. No. If there's an error waiting. We did have a handler for that somewhere here. Wait. Yeah, I'm just gonna copy that. Actually, wait, it's in here. Alright. Now we don't really, I don't think we can, do we even care about the terminator? We might care about the termination actually. Oh shit, that's gonna be a whole other thing. The the termination thing, that could be part of the stream then. Yeah, the error of the stream errors with whatever. You could have an exit code actually. Okay, but that's a future problem. We could just embed that in the streams. Some kind of metadata somehow. Okay, but anyway, so let's just don't forget about it here. However, we need some way to kind of push that data. Maybe I mean, we would have that. Actually, we would actually have those. Actually, this could be an auto array hash map for child IDs. Yeah, let's make it a hash map for child processes where the key is the ID. So then if we have the ID, we could just grab it from here, which means that, well, when this pops, I guess this also, I mean, it does kill this list here. So we don't really have a way to store, we need a way to store the termination signals, I guess. That could be another context. We could also have like a special thing here called wait, which will wait on everything, and once it's done, we now have all the termination signals. And once that's done, we can then, the caller of wait could use that information to the, so basically we could have wait, and this could return, let's just return a hash map maybe. No, we don't really need a hash map. We call wait, which I guess could be an error, and we will do this here. So we'll wait for all the children there, and now these are actually values. Okay, so deinitialize will just, this will just deinitialize the thing. But there might be processes that we actually need to wait for. So we'll wait first. I was thinking like we should return like some kind of result, but we don't really know how to handle those. We just need to. This is going to get populated with termination signals. Like each child will have the terminate signal populated, so we can just look at that after calling wait. So you call wait first to that that will block until everything is done, and then you can look at the terminate signals. When you deinitialize, we need to wait first so that we make sure that we don't have any children we need to wait for, and then. Is it an error to wait again? No, it just does this. Wait, what do you do? Okay, so that should all be good. Okay. And then we will deinitialize this one. So that's just gonna be deinit. And we need to actually pass the allocator now. Oh, there we go. And if something goes wrong here, I guess we'll catch and log, but we don't do anything there. Error when waiting for command. Actually, we catch the error, but we also return it, I guess. So we don't need to log here. We just catch and don't do anything actually. If it's an error. Like in the initialize, I usually don't want to have to take care of a bunch of errors because of the defer deinitialize pattern, which doesn't allow to have a try there. So we just catch it, and the logging already happens in here, so we don't need to log anything. So it's already basically handled. It's just that the error bubbles up even though we're logging out as well. In this case, it might change later, the pattern here. But yeah, okay, so now we have this context here. So we also want a function that will, let's move you down here for convention. Init, the init, also always together. Init first, the init second. And then we're gonna have, I mean, I guess we could have like a spawn. Or yeah. So basically, I mean, we could have like, I guess register, and then we would take a process description and then store it here. So we would return a child. Wait, but we need the ID though. When is the ID created? Available after calling spawn. Okay. So we basically have to create the child first and then call register here, but now we need this to be source of truth after that. So let's call this spawned child. And then this would be processes, put spawn child ID in with, wait, you need allocator, right? Yeah. And the value is spawn child. And then we return, I guess get or put we could use instead. Do you, now you don't have that, and then we do entry dot value pointer equals spawn child, and we return enter value pointer, which is the pointer to the child. There we go. Right, and the command is gonna be child. Is this stored here? Yes. Cool. There we go. Alright, so now we have a child context which we can use to store a bunch of processes in. We can wait for them, and we can also grab out their term signals. Could add a convenience function for getting the term signal of a specific child. And this would be the process ID. And we would get, I guess, a nullable term signal, which would return processes get ID, or else return null, and then we return child dot term. Oh, so this could be an okay. So okay, so it's if it's an error. If term we get that out, that should be T, else we get error. Right, we return the term. If we get error, we just return null. Now we could return the error as well, but whatever. All right. Because we could, that's probably gonna get useful when we try to find the terminate thing of a child. So let's add this into our repertoire of things. Process, child process context, or maybe just a process context. I don't know. Spawn process context. I'm not really sure what to call this, because it's like it's supposed to be you're gonna be able to use it to wait for processes to be done, spawn up a bunch of processes and then wait for them. Yeah, whatever, that's fine. Processes. Init processes context. We don't need an allocator. It's gonna be processes. Init with nothing. There we go. Then we have the initialize. Now you need an allocator. Oh shoot! I mean, I guess we could store the allocator in there. I guess. Yeah, fine. Instead. All right, and also here. All right, cool. So yeah, we have a whole bunch of errors, but don't tell me I created like a 2A now. Where were we? Okay, now. Oh yeah, also we need a push function. Push push processes. There we go. All right. Let's go back to evaluate pipeline. So, I mean, okay. So, I mean, I guess instead of having the child map here, we can actually now just create a context around the whole thing to handle that. So, yeah, let's just get rid of this actually. And I mean, it could still be used, but I think if we're gonna have something that will, some kind of context we need to take care of, it's actually more generic now, because you could detach the context, put it in a context list instead, and then whatever context we have that we need to take care of, we can like cold initialize on that instead. So then this one is actually, okay, now we need some, let's have some convenience functions for frame stuff. So let's add like spawn, I guess. And then we actually, we don't want to move all this there, but what we do want to do is look at child init here. So this is like argv allocator, okay? And then spawn is just called. But what we want to do, yeah, we want to call spawn after we set all the config. So basically, we maybe want to call spawn in there instead. Perhaps. No, but let's just take a child that we call spawn on, maybe, and then just return the error. Yeah. So spawn, and then this is the child, and then we're gonna return a pointer to the child. So if they want, if you want to use the pointer somehow, you can do that. Now we are gonna get the frame, which is gonna be current processes frame, which we don't have as well. We need to create this. Really want to generalize this pattern here, but it's also very easy to copy paste. And this would be processes frame, and you change the process. I mean, it's really just changing this, so it's not actually gonna be super difficult. Current frame by tag. Tag is well, that's the tag of frame. And you are the tag. And that's it. And then Actually, we can just remove all this now. So this would be like current frame by tag. The tag is single. Allocating. Okay. All right, so that's the frame. Now we can say frame register, whatever we called it. No, it processes register, yes. Child. Now this needs to be spawned, so we should just say actually let's copy it, I guess, or we could send in, let's just send in that. So we spawn it, and we do try there. And register, which we then just return. And that's it. Okay. So now instead of doing this, we do scopes spawn, and we provide the child there. So now it's gonna get put into whatever context we have that is like the current child context. And we can go to here whenever we add a new main thing, we can actually add a child context. Let's add it here, I guess. It doesn't matter that much. So we'll just push another thing there, and then pop frame will add one pop. All right. So now, yeah, this would find whatever context is closest to the, like whatever child process context is closest, put the child in there, spawn it, and yeah, so then it's put there, and then the evaluate pipeline will be able to create this new processes context, and then at the end we'll also pop that. But before we do that, we can also decide to get we can do, what do we do? Well, we can have a function called wait, I guess, a convenience function. Which will wait on the current processes frame. We could also make this public, where you could look for the thing directly and wait for it there. But let's do wait, and then what we return is going to be the frame that holds the thing. So let's do like pointer to frame.processes. let's say. Or just processes, yeah. So we'll get the processes that we waited for. Wait, is it framework processes or where is this? Oh no, it's called child process context. There we go. Okay. So first we get the frame, and then we say wait processes. And once it's done, we return frame.processes. So we can also access whatever data we need to access there. So now in evaluator, we can do wait. So that will now take whatever process context we had and wait for all the processes there. And at this point, we should be able to examine the term signals of the processes and handle them accordingly. So basically, for example, if this process was errored first, we could look at that. It's also the case where we also want to have like a generic error or exit code that we want to encapsulate in the reader writer streams. They should also be able to encapsulate that, because the executables, they can give you some kind of exit code, but then the functions also have like a typed exit code, you could say, which we also want to be able to encode in these reader writer streams. So yeah, that's what's gonna happen there. But for now, I'm just gonna ignore all these things, and if something goes wrong, it's gonna get logged out, and then the execution is just gonna continue, basically, I think. Well, I guess we'll see what happens here. So, but now at least we can spawn up these things. We can connect them to each other, forward all the streaming bits back out into the the actual standard out and standard error and all that. And then wait, is standard error actually? Yeah, standard error is also connected to whatever. It's inherited, I think. Actually, we don't even have. No, it's inherited. Yeah, and that's also a reader writer stream now. So, so that should all work out. Okay. Cool. It turns out like the context thing is like super important. Like that is, and it can solve way more problems as well than I thought, actually. Now what is this here? Wait for process. So I don't think we'll ever use this. I'm just gonna say that we don't actually use this, and we also don't use this. So I'm just gonna do that. All right, we're gonna have a whole bunch of errors now that we need to fix. Also, thank you to Oscar Allen for following. All right. Unused? Really? Did I remove a bunch of logs or something? Okay, let's just remove this down. Yeah, remove you. You are inherited. Do we even need this. Couldn't we just say inherit here? Yeah, why are we just not saying inherit? Actually, we could just say inherit here. Okay. And standard error is always inherited. Good. Okay. The next one, yeah, we don't need the next one. We just need to forward these now because they are already set up. Cool. Now, when are we done? We are done when all of these are closed. And after that, we do a wait. So let's now check here, I guess. If something is not closed, we will continue outer. Otherwise, we will... What would this else be? Where is this else connected to? Is it the for or the if? I guess we know if we do this. So basically here is like, if this for loop is exhausted, and which means that none of these were open, then everything is closed. So then we break out of this loop. I guess we could just say break because it should automatically target this one. But otherwise, we will... Actually, we could just say break here as well. But it's kind of confusing though. Like, yeah, if this is break, else break. What? I think this is more... maybe more readable. I don't know. Well, basically, we're just looking for if we're going through every closed... If one of them is open, we still have work to do. If wait, we shouldn't have this anymore. There we go. Yeah, so if one of them is closed, or open, I mean, we continue with this loop here. If all of them are open, or closed, I mean, then we never went in here, and then we go into the else break. And the break it could just as well be down here. But, I don't know. I just like using the for else. Okay. Man, imagine this working first time. It probably won't. Okay. Now we have a whole bunch of fixes probably to do. So let's just try and get through them here. Okay, you're an expression. Actually, well, this is an expression, so we can just do run expression now. There we go. Cool. All right, what is your issue here? You are not that. You are this. Right splat. Oh yeah, we need to return. There we go. Also here. And we don't do try. We just return. Same thing here. Let's just do return. And return. There we go. Okay. Okay, what's your issue? Expected iWriter, const age, use size, right fade, use size. Oh, it says void, okay. Use size. Expected error found, use size. Well, what are you? You are use size, so you should be use size here. Expected iWriter find iWriter allocating. Ah, so you need to be the writer. There we go. Good thing we encapsulated that, because now we just needed to change that one thing, and it all works out. What is this now? What do we have here that we didn't have before? I wish it would tell me, because we have a whole bunch of stuff in here. Pipeline deprecated, I guess. Okay, I'll just ignore that. Pipeline stage. Right, so this would just be this. Expected type, stream reader, writer stream file, iWriter. Right. Okay. Now. Okay. Yeah. So the whole process standard in we just ignore actually. And but now we could use it, I guess. We could connect it up. I'm gonna add a to-do here. Connect up standard in from parent process or something. I don't know what to call this. Alright. And then you guys need to be the reader writer streams. So let's just create them here, because this is the outermost context. And we'll just do standard out stream is gonna be reader writer stream initialize. Hang on. Where is this? No. Okay, yeah. This is runic. There we go. You need allocator. Okay, standard out, standard error. There we go. Oops. There we go. Okay, now we got a whole bunch of stuff. Okay, so you're actually in it fixed. And you, I think you duplicate. No? So actually let's actually duplicate that. Wait, yeah, because the value, yeah, we get the value in here, so let's do, yeah, let's just do Duke. That's fine. Expected type, stream U8, stream that U8, right. Also, we're not really transforming values to strings here. We're transforming them to bytes, which doesn't work. But transform to okay, let's do this is kind of weird. Like the map thing is weird because we don't really know how large the destination is gonna be, so we can't really buffer it or anything either. So yeah, this whole map thing, I think I'm just gonna scrap this. Actually, it's gonna have to be some kind of super specialized thing. I mean, we could maybe have some allocating buffer actually. I mean, yeah, sure, but I'm just gonna disable this for now. I'm not gonna solve this issue right now. We have too many other things happening here. All right, so what are you doing? You're trying to render pipeline stage. So we actually render an AST here instead, or expression. There we go. Okay. Child map, right? So we don't have this either anymore. So let's get rid of you. Very good. We have a whole bunch of issues in scope. Processes. Oh, where's that thing? Must handle all possibilities. Yeah, I guess we have allocating as well. We could store some more information here. We could like say, okay, well, how large. Can we get that actually easily? Can you get that here? No. Can you, well, we could get this maybe size. We have to sum it up, I think. Maybe it's better to say how many items pointers. Count, because it's a hash map. All right, we have a whole bunch of shit here. You are the stream. Pipe reader info. It's like this is not even gonna be used, so I'll just remove that. It's not even a thing. This is like, this not even a thing. This is just pipe info actually. Yeah. Expected type, blah 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 blah. Const. Oh. There we go. Okay, only two things left. Expected this, found const. Fixed it for you. Find in frame. Okay. Value. What did we add here? What did we add? Process. But the okay, well, I guess fine. Now let's do print, because we have the ID. We could just show it like process. Oh shit, it can be like a pointer. Yeah, that's the Windows one. It could be void as well. I mean, I guess we'll put any here. All right. Okay. Only 3 compiler errors left. How many bets do you want to make? How much do you want to bet that this will work first try now? When we get this compiler sorted out. Okay, forward string stream. This, well, actually we do we use this? Yes, we do. We are using that value as a stream. We're trying to turn things into a stream and then we forward it. That is correct. Okay. So yeah. Oh yeah, so you are the stream. So that's the standard out stream. Yes. Oops. Stream.stream. Oh. Right, stream into standard out stream dot rider. Yeah. And it's like, this is so weird, but it's like, okay, well, if we're supposed to, if we have like a file descriptor that is backing this standard out stream, we need to flush it, which is basically what we're trying to say here. But it doesn't it's not really super clear. So I don't actually know. Like, we could maybe try to encapsulate it into the interface implementation. Maybe connection type, like do we also need to flush the standard in? I guess it depends how much buffer we have. Like when we create these things, they all have buffer 0, so they should just be forwarding the things directly. We don't even need to. I don't think we need to have any flushing going on. It's just gonna forward it directly. I think what's happening is, like, when you use like the built-in standard out, like the standard file standard out, and then you create a read or a writer. This buffer, if this is like a buffer with whatever, it's gonna fill this buffer before actually sending it to standard out, I think. And flush is really just handling this buffer. So if you don't put anything here, if you put an empty buffer, I think it's just gonna do it. I mean, we could try. We can actually. Oops. Rider. Let's do like rider streaming, because that's what we have, and let's do empty, and then we do like, well, this needs to be a var. Do you need to be a var? No. So let's do like standard out. Actually, do we need to close this? It's gonna close itself. Then you need to, then it's like, no, file writer, and then interface, and now let's say we print something, hello world, right? But probably we can't just, well, I guess we could try this out. Have to do try here. Expected to work. Oh, because we use print. Okay, so it does actually do it, but let's say we sleep here. What is that? Thread sleep or something? Nanoseconds. How much is that? So milli, micro, is this nano? Sleep for 2 seconds. Yeah, it just drains it out immediately. Hello, as is Code Hub. Welcome. What's up? All right, so this kind of proves that if you don't have a buffer, it will just flush it out immediately. If we have a buffer, let's say we have a buffer of whatever, and we provide this buffer instead, now it will wait until sleep is done. Oh shoot. And then print hello world. Or not print anything at all, actually. But let's do flush. Yeah. Yeah. And we can do like going to sleep before waking up. Yeah, there we go. And then if we remove the buffer, it's gonna print it immediately and then go to sleep. All right. Yes, hello, I did answer you. I said hello as is Code Hub. What's up? What's happening? Pipeline. We can do this now. Yeah. Hey, dude. I did answer you. Couple times now. Switch my sound on our buttons. Now we have like a process. We don't really. Wait, no, we don't. Why not answering? Answering what? You haven't said anything. You haven't said a question. Okay, what are we missing here? Deprecating, okay. Well, that's gonna be down here. Who are you talking to, Aziz? Aziz Light. Yo, Rukutuki. That's a crisp sounding keyboard. Yeah. It feels good. Okay. So, I don't think we need to worry about this actually. Because we could just say, we could just have all our writers not being, you know, so that they don't have to worry about it. Expected type. Okay, I'm gonna do something here. Could you? I'm gonna time you out. How do you do that actually? Okay, I pressed some button, I don't know. Expected type, error, end of stream, read fail, write fail, boo, ba-ba-da-ba-doo. Yeah, that's the first one I had since I started streaming. It was bound to happen, I guess. End of stream. Read fail, write fail, boo, found void. Oh yeah. So if we don't have a source, I guess we'll do false because we haven't connected yet, so we don't really know if we're done or not. Okay. Lookup. Well, allocating processes. Format value. Didn't I do this already? I have like another. Place maybe. Clone the process. Well, that's just gonna be up here. Can't really clone a process in that sense. Materialize string. Yeah, I guess the process could be materialized into something, but I'm just gonna, because it's probably not gonna get used anyway, so I'll just do that. Actually, you know what? No, I don't know. Anyway, I'm just trying to get through all these errors so we can test this out. Okay, now what's happening here? Execute binding. Oh, that's right. Okay, we got a bunch of allocating writers. I think what we need is well, actually, yeah, we need reader writer. We need reader writer streams that are not connected to any output. So we're gonna have like standard out stream. It's gonna be reader writer stream. And then standard error. Alright, now you are gonna be standard out. Actually, we could just call them standard and standard, I guess. There we go. Okay. A value pipeline. So we're missing some kind of error code here. So what is that? That's probably coming from this wait thing, which includes this one, which includes this. So this wait error we need to add to our list of things. So you actually are process child wait error. Is that enough to get you working? I don't know actually. Oh, we got a problem over here now. Declare current. Oh yeah, so you need to be current frame by tag single. Okay, and then you need to be like wait plus this error. So it's just gonna be error plus process child wait error. There we go. You have to do that. Yeah. Cool. Now we have to go to the error here and add the wait error here, which should include spawn error, I think. So we can just remove that as well. There we go. Oh, still what? Okay, maybe there's something else as well. It's doesn't even fit in the error message. What do you return? You return a void. Okay, that might be the issue. Right. Okay, so here is the thing now. Okay, now we're at the issue of what should this return? Because it should have already been streamed out to the outer context. And so, I mean, I guess we could return a value and we just return void. Because we don't really have any meaningful thing to return. I mean, I guess we could return a bunch of, we could return like the pipeline descriptor or something, but no, let's just do that. Okay, so where are we now? Evaluate member expression inner. Right, so you have, I think it's process. And value of type child process context is ignored. Right. So we could now potentially get the context. So this is the process context, processes, and we could look at, we could get the term signal for whatever ID we want to get. But I'm just gonna say, I'm just gonna do this for now. And we'll maybe do something with that in the future. All right, back here, closure. We're going back and forth. What is this? Closure, right. Closure, what does that mean for allocating and those kind of things? Okay, so right now allocating is like it's used for the processes to store file readers and writers. And what would that mean for a closure? I think the closure doesn't really care because the closure is not part. I mean, I guess, okay, it could be that you're defining a function as part of a pipeline. You define a function in here. Now this has a closure, which is this context, this whole thing here. How will that work? I don't think it cares about those kind of hidden variables. It only cares about things you can access through bindings. So we could probably just ignore that. Yeah. So allocating and processes we'll just ignore. Right. And do we need this child? Yeah, this should take over, like child equals that, except it's the wrong type. Couldn't you do this? You define this pointer as part of this scope, local scope, right? Because this should belong to this scope out here, not like this scope. So it's gonna be, you're gonna be able to do stuff with it, but then we just reassign it here to the actual pointer, like the permanent pointer here. Oh, but now it acts as of. Okay, couldn't we make this? Can you make this mutable somehow? Constcast. What? Oh, no, that's okay. No, this needs to be a bar. Yeah. It lost the type. How does that? Will this even work? Like, I don't know. It might be some compiler weird stuff happening here. Whatever. I wish you could remove the I wish you could do this. Okay, well, anyway. Maybe we'll do equals undefined. No. There we go. All right. Well, we've come a long way from like when I first started Zig. Things like this was like the bane of my existence. Like thinking about local, well, thinking about like who owns the pointer, when does it get invalidated, how do I even do things, how do I return a value, like what's, you know, it's still an issue. Like if you initialize something that needs itself as a pointer to set up some buffers or something, that doesn't work. You have to like do it afterwards or send a buffer in from outside. It's pretty annoying. I wish there was a way to get like the target, like let's say you have an initialize function and you would get the kind of the address of the thing that gets bound to it into the function. So basically like you have this init function and you would get well, or they could be let's say this returns, I don't know, some kind of struct, let's say a value, for example, and then this would return like, I don't know, some kind of no, actually, let's do standard IO reader, or yeah, let's do that. So if you have a buffer now, no, wait, actually, now let's say you want to return a struct that has a buffer, which is like, no, god damn it, what? yeah. Let's say you have a return struct that has a buffer, okay? So let's say it's 512 something, whatever. And then we have a reader as well, which is a standard IO reader. And you want to kind of make this buffer part of the reader, right? Okay. Well, in the init function, we would have this, you know, the buffer is undefined. Let's just remove this because maybe it becomes a bit clearer. But then the reader, you want the reader's buffer to be an address of whatever this will be. But we don't know the address yet. We don't know what address this is gonna be. We just know that whatever address is gonna be the result of whoever called the init function. So let's say someone called this init function like buffered reader or something, and it's just like init, and then yeah. So we don't know the address of this that we're like assigning it to. So we cannot say, well, this is going to be the address of this buffer. Well, we can't actually use that. Unless you can work with like relative address, but I don't think you can. Like relative address, so what's the relative address of whatever starts here and then this? Maybe that could work. How about that? Relative address of a struct. So first you have this, the address of this struct, and then you have the relative address of this field to this struct, and then you assign this to be relative to this. I don't know. Because that could work like in if you were working like with assembly or something. Then you could do whatever you want. I mean, you could do it here as well, but you would have to have some kind of other construct for that. What's happening here? I just want to get back to what I did just before. Okay. Yeah, but those things, like they really tripped me up at the start. I feel like I've gotten a lot better with those kind of things, thinking about, you know, yeah, ownership of the pointer, at which point does it get invalidated, when do you need to allocate the stuff. Like first when I tried to start with Zig, I tried to make everything non-allocated. I tried to make everything like on the stack, but that doesn't work in the end. Like as soon as you need something that is that needs some kind of dynamic size, it doesn't work anymore. But it could work for a lot of programs maybe, but oh, that could be a stream error. Okay, sure. Is this the last error now? Expected blah 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 found this. Okay. Wait. Oh. Okay, so this returns a thing there. Yeah. Are you even? Yes. Okay. Wow, no more compilers. Ah! How much do you want to bet anything will work now? Let's do an example here. Well, we have our little thing here, so let's try this out. Let's just do the normal thing first. Of course, it doesn't work. Okay, why is this happening? Oh, it's type checker. Okay. Yeah, forget about the type checker. That's not gonna work. Okay, there we go. Well, not even the most basic thing worked. Okay. We're off to a good start. Oh, and we get general protection accepted. Perfect. And it's over here where we're fiddling around with the pointers and stuff. So why do we get it here? That is very strange. Okay. So where did this happen? 1401. So is it argv or what is the issue? Get context argv, self allocator. Oh, wait. Right. Okay. So what's happening here is pretty obvious now that I see it. Okay, we're declaring this to be a pointer to a child. But where is the child? This is just a pointer to a child. It's not the child itself. And then we're trying to populate this pointer, which is undefined. Of course, it's going to be general protection. So, okay, this is how this is basically. All right. Let's just do this. Let's just do like var child is is this. All right. And then we don't do this. We do. I guess stable child, which we kill here, the process, and then we have these things that we now use instead. All the child references we will use stable child instead. There we go, stable child. There we go. You are this. All right. No more errors again. So let's go back. Okay, we still something is happening here. Allocation alignment 8 does not match free alignment of 1. Interpreter scope 1043. Okay, well, I have an inkling of what this is. Wait. 43. Create, allocating, allocated, create. Well, that's the create. Okay, that's where it allocated. Where was it deallocated then? Free 287. Oh, are we supposed to? Okay. No, wait. Oh, I see. So we're basically saying that you can't free something that's been created, even though the pointer itself is like is this? You can't call free on it if it has been created by a create, I guess. Okay. So it kind of, okay. I mean, okay, we could just use allocate with one item. Is it gonna complain about that as well? So let's do like alloc 1. Actually, let's just return. Yeah, let's get allocated is equal to try self alloc t1. Boom. And then we return allocated. I guess this, if we want to be super whatchamacallit. Okay, more issues. Wait, did it build? Yes. Same issue. Wait, what? Okay, so the allocation is here. Yes. Alignment 8 does not match free alignment 1. Okay, so there's something weird with going on with the pointer then, I'm gonna guess. Maybe we... okay, maybe we'll do this. Maybe we'll just allocate it as the string of bytes, and they will convert it. We'll do like a pointer cast or something. Now that should still be the same thing. We just need to change this. Allocate, so let's do U8. Let's do like as bytes. It's gonna be slice as bytes. Oh, we don't have a slice though. Why can't we just use like size of t? And then we have to do like the alignment thing. But that should be part of the pointer that we get, right? Oh man, I'm feeling this is starting to become like a rabbit hole here. No, that's not gonna be. We just do like size of t. Right? We allocate that, and now we don't even need to. No, we store it as it is. That's the pointer. And it's going to be times n. Although now we have an issue, I think. Like, I don't know how much is stored like in the type metadata, like if you could use any opaque pointers, maybe, I don't know. Maybe we could use any opaque. I have no idea. Now this looks at like the type info and shit. Slices, bytes. Okay, well, let's just do it. It's not really gonna be a big issue, I don't think. So we're just gonna allocate whatever size times n. Then we're gonna say that's fine. We append this in there and we return the allocated, except we need to convert it now, which is the issue here, because when you convert this, we're gonna do like bytes as slice. I'm not even sure if this is gonna get converted correctly here. Because of like alignment on each, like this is like a packed array where everything is packed together, and this might not work here. Returns a slice of the specified tied back by those bytes, preserving pointer attributes t0 again, blah, 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 blah. Okay, I guess we'll just try it out. Bytes as slice. Okay, what do we get out? Is it a slice of t? Or is it just gonna be t? It's just one item, I think. Maybe we need to loop through, actually. Maybe we actually need to... We'll do it a bunch of times. Yeah. Let's just do that. Let's do create. Actually, let's do create. No, allocator create t. No. No, we'll allocate. We'll do allocator allocate. U8 size of t. As a slice, what the hell? Okay, whatever. Let's just do as value t allocated. Given a pointer to an array of bytes, returns pointer to a value of a specified type backed by those bytes with some pointer. Okay. And now this one is basically just going to be a bunch of those. And actually, oh yeah, and then we do self. Oh shit. We get this, and then we do frame allocating pointers append frame allocating allocator item is allocated. Okay. And you will basically okay, I guess you do the same thing, except this is like slices. No. Bytes as slice. Yeah, I mean, let's just try it, I guess. Append the whole thing. Sure. Okay, well this gets us, this doesn't get us the pointer. I guess this is like a pointer cast. Let's actually try without a line cast. I don't know. Usually you have an align cast. You have to have an align cast with a pointer cast. Yeah. I don't know. I don't know if this is gonna work. This feels very, very iffy here. I guess we'll find out. Okay. Well, it didn't freak out. Let's enable the executor logs. Okay, so things are happening. We have a whole bunch of, these are all the envors. I should probably like not show that. I don't know. Well, it's just the names of them. When did you start learning Zig? About a year ago. I started when it was 0.13, I think. That was the stable version. And now it's 0.15. Okay. So we're evaluating this. So basically, let's see, where are we doing the allocating? Right. So here we are. Well, that's the main thing. We should have like another processes. No? Don't we have evaluate pipeline? Oh, it's not a pipeline. Ah, it's just a call. Right. Well, that's gonna, I mean, it is still gonna spawn the process and connect it to standard out. And then at the end, we wait for it. But why doesn't it? Okay, we spawned the process. And Yeah, that should have forwarded it to standard out. What kind of resource do you use to study it? Currently trying to pick it up. I mean, there's not much resources out there. I just used my previous knowledge and, you know, read documentation, looked at a little bit of examples and stuff. So yeah, it's I love to explore program languages. So basically, I just, you know, started using it basically, and I don't know. To me, a lot of things make sense. Some things are like a little bit quirky. You gotta get used to it, but you can't really rely too much on. I mean, the documentation is good in places, but it's lacking in other places. And there's not much on Stack Overflow and anything like that for like specific questions and stuff. There's some stuff on like the issues in GitHub, but mostly you're basically on your own. But if you wanna get to know the basics, you should check out zig-links. If you haven't done that already. And do you want to also get? Hang on. So this one is a bunch of exercises you can do to kind of learn the super basics of the language. Or well, it's gonna go through like all different kinds of things you could encounter, maybe like syntax wise. You're gonna learn like basic syntax of the language, and I think one or two maybe standard library function things. And if you want to install it, then you should check out, where was that? This one. ZVM. I use this one. I think it's good for like installing different versions of Zig. It's the version manager. I don't think it's official, but I use it and it works pretty well. And what else? Then you have the language server, which I use this one. Now the language server is like still, you know, under heavy development and stuff, so keep that in mind. But basically you could use it as, you know, a normal, any kind of language server. All right. Okay, so I think what's happening here, it is like we're connecting this up. However, we're never reading from, we're never streaming the thing. So I think we need to set up this content, this kind of like even if we only have one call, we need to set up a pipeline anyway to properly handle this. So, but the problem is now in which context this is going to happen. Because it's not going to be a pipeline expression. It's a call expression. And we don't want the pipeline itself to set up a bunch of extra things. No, we should like make this, like if this call function is part of a pipeline, we don't do anything. That's the thing. If it's not part of a pipeline, then we need to kind of treat it as a pipeline. Yeah, no problem. But okay, so this is the weird thing. Like this doesn't work. But however, if we do this, this might actually work. Or we can get errors as well. Okay, what is the actual errors here? Or what happens there? Double free. But do we actually get a hello? No, we don't. Okay. Okay. Let's get this. So get an RC issue. Which one is this? About expression. Okay. And then maybe state, maybe value. Right, double free. Okay, so that should like double free that. Well, here's the first free is happening when we. I'm guessing this is the initializing the scope, maybe. We're deinitializing the function in the pipeline. Are we deinitializing this and then returning it? We're deinitializing again. Hang on. What's happening? Evaluate. $937. Okay. We're looping through the pipeline. We're evaluating some expression, deinitializing. Why would that be a problem? Is it something wrong with the cloning? Because the thing that gets, it's the function, get the function value, right? Yes. You're just a ref. Hang on, this is missing a thing. Okay, I'm not sure if that was the actual issue though. No. Maybe. Oh, that seemed to have solved something, maybe. Or was it the other way around? Like we shouldn't have this. I'm just grasping at straws here. No, now we get, okay. I think it's something with the function being cloned. That's the issue. It's not properly cloned. Well, the clone just refs it. And that's the issue, I guess. You are a actual stream. Yeah. You get refed. But that shouldn't be an issue, though. Like, the ref, it should, like, properly handle itself. Okay, well, let's enable the... the logs here. Let's do executor and also RC. Was it RC? Whoops, lazy. Yeah. Segfault. What the hell? Segfault at Android 69. Not allocated. Event expression. Pipeline. Stream then, okay. Okay, these ones. Is it because this deallocates it or something? Forward, where's the forward scope? No, we don't do anything with that. Hang on. Are we doing this? Are we not doing this the correct way? Oh, wait. I'm stupid. Okay, wait. We can't use the reader writer immediately. We actually have to make this thing here. Yeah, okay. Init. I mean, this could really be like init implementation, but init reader writer, we have to do this because this sets up properly the ref and everything. So yeah, init reader writer doesn't take anything. We will get a stream out. Although it's probably better to return like the reader writer stream instead here. And this is reader writer stream ref reader writer stream. There we go. Alright. You don't need a buffer, you're just that, and we don't even need to try. Okay, I actually don't even need the allocator, to be honest. No, wait, we do need the allocator actually. I'm just kidding. There we go. All right. Now we should use this one instead of actually calling reader writer stream directly. So actually this doesn't even need, well, it could be public because we want to refer to the type. But whenever we call reader writer stream.init, we now actually call stream init reader writer instead. Wait, what was it called? Init reader writer. Oh. No, yeah, that should be init reader writer. Init reader writer. Why is that? Oh, because of this, right. And we do need an allocator, there we go, okay. And are you now a, yeah, so now we actually need to try this, there we go. There we go. And now you can actually const. Okay. Oh yeah, so now we can just return that. Okay. No? Not allocated. Okay, there might be some other place we forgot. Reader writer stream. You're not used anymore. Great. Ah. Right. This one. Well, you know what? Let's actually do like a pointer to a stream of U8 instead. And then you would be like stream. No, actually. It's gonna, no, it's gonna be a pointer to read writer stream. This is gonna be stream U8 init reader writer try. And actually, oh yeah, that's right. There we go. Because this is a pointer to a pointer now, so we're setting the what the pointer points to, and it points to this pointer here. All right, but you don't really need to be a pointer, and you don't need to be a pointer. You don't need to be a pointer. And you don't need to be a pointer. Okay. And we don't need to free. Because it's gonna get... No. Yeah, the list is... Yeah, okay. The list needs to be freed. Okay, yeah. That should be fine. Anything else? Scope. of course, has the reader writer stream. That's where, no, that's not where it comes from, but it's used here. Okay, now we got some leaks instead. Something's happening at least. So that's the init main. Let's see if we actually get the output here. No? Okay, so we still get this. Except we get even more errors now. Okay, let's see if we can fix these leaks first, because they feel like they're maybe easiest. I don't know. So we got some RC, reader writer stream, ref init. Interesting. Oh wait, that's in the outer file. These ones, yeah, okay. So we just initialize those. That's fine. Okay, so we got a seg fault. Okay, we got a seg fault now when we try to deinitialize these things. Weird. Wait, RC equals null. We get a seg fault when we set it to null. Stream 300. I mean, it might be order of operations error here. Maybe. Alright, so it's probably this one. I just initialized and then released, and then there's a seg fault that like immediately. hang on. Oh wait, so this ref is like, oh, it lives. Okay. I see what's going on. This ref lives on the same pointer that is being destroyed. So this pointer gets invalidated. So this ref is now in invalid memory, but we're trying to modify it over here after the release. Let's do it before. Well, we won't actually know if it's going to do it or not, but I guess we'll do a check here, like if RC refs is equal to 1, we will remove it. Because the idea is that this would return true if it was invalidated. But we don't know if we could modify this or not. Well, let's just do this. And this would only change, like, be an error if we somehow change how the inner workings of the RC works. But yeah. Oops. Okay. Promising. Well, not allocated, it says. Script execution error not allocated. Warning, RC called release of non-allocated released RC. Okay. Okay, it's still happening. Okay. Current working directory. No. Wait. It's this one. Push. Yeah, it is the current working directory. Okay. Probably. So it gets initialized here, I think. Yeah. Yeah, this is the first occurrence. So it gets the initialized here with a dupe. Fine. And then we just release it. And that's fine. So now it should be deinitialized. When are we deinitializing it actually? So I think it's like we're popping the frame or something. Are we popping everything? No, we're pushing the frame. And then we pop. Frame 9 forward context. Oh, that's the closure. Oh. Okay, so the current working directory, when it's cloned into the closure, let's check what happens there. Closure. How does this work? This is a ref. And we're just storing it. We don't actually ref it. Okay, so we have to ref here. Yo, bar checker, what's up? Okay, we have to ref it, so it becomes another ref that we can deal with. Okay, now we get leaked memory instead. How's it going, Barrel Checker? Now we leak, and we're leaking. Read write closed. Where is this? 942. Closed. Oh, is this even used? I don't even remember this. Oh, I was like, what? Which reader writer is this? Well, this is the state to determine if they're closed or not. So, okay, this is never freed. Okay, well, that's easy. No, we don't need to try that. There we go. Goes how goes. It goes how it goes. Okay. No errors, but also nothing else either. Okay. Well, I don't care about RC anymore. Let's just do the execution log. Okay. We're doing a pipeline. Of course, we get this, we evaluate this expression, we push forward in frame, we do that, we execute function declaration. What? Oh, okay, I see what's going on. I think we need to take care of something here. Parse. Is it pipeline? No. Parse, maybe binary expression. Now let's apply. Pipe. Oh, I think it's done in the evaluator actually, maybe even, probably, maybe. There's something like create executable something something. Yeah, this one, we don't need this anymore, I don't think. I don't think we actually need this anymore. It's like when we, yeah, we evaluate an identifier. We should just evaluate it directly. We don't actually do all this crap. We do a lookup of the binding. If we don't find the binding, we do kind of like a function declaration, but really this should be the expression. The expression is just, where's the expression? This one is just this. Executable with the span. That's all it is. Create executable expression. Okay. Because before I was like, hey, we need to create a function, like each part of the stage of the pipeline is a function that takes a standard in of string, and it, you know, we have to turn it into a function that takes that. But I don't think we really need to do that anymore. We don't really need to do it anymore. So, because we are setting up the context instead to use that. So what we do, I'm gonna do this, copy, and instead of doing all this, we're just gonna do create self-executable expression, identify span. And the reason why we do it here is because we don't know, we don't have, what the hell is your issue? Oh wait, we don't need to create an executable expression, we just need to execute it. We'll create one without allocating, and then we will return evaluate expression. Executable expression. And this is an expression. And the span is identifier span. Alright, so basically any identifier we don't find is going to be executed directly as a thing. If you have a statement that is only one identifier, otherwise it's going to be a call. Okay. Let's see. Oh. Are we not finding an experience? Wait, I thought you would set that up. Maybe you didn't. Obviously not. Man, I thought, oh, it's the run function that maybe does it. Okay, let's check this again. Or maybe we just need to wrap it in a call. No, but then we need a function. Actually, what is this? As an AST. So it is a pipeline. Oh yeah, no, yeah. It is a pipeline. We call, it's a call. We identify, okay, that's why we need a function, okay. Why? Wait, what was the issue? We create a function. Okay, if we go back here now again. Let's go back here. What was the actual issue here? argv was like not supplied or something. Why do we not get an error now? What did I do that I didn't do before? We changed this. Body is an expression. Yeah. It's not really any different. Well, I am confused. Also, this doesn't seem to work. The process wait seems to work, but this doesn't seem to work. Because it's not forwarding to standard out. Okay, are we forgetting to kind of forward the outermost thing as well, maybe? But the last standard out. I mean, we could also maybe we could label the streams so we can see what's going on, maybe. Because there could be some issue going on here. But basically what I'm trying to figure out is like, okay, well, so the first one, standard in, is blocked. Standard out goes to the first reader writer stream, which is then connected to no, not standard in. Standard out is connected to the source of that. So that pushes into that now. And we call forward on that, and then that's connected to the next one, the cat, through the standard in on the destination. And that should now get pushed through whenever we call forward on the stream. And then the last one should connect standard out to the standard out in hand. Okay, so do we actually okay, let's do evaluate pipeline. We need to also grab the inherited standard out Because we're forwarding like all of these, but we're not forwarding the standard, the actual outer context standard out. And also not standard error either. So scopes get standard out. Standard error. Except no, I think we need to forward those. Maybe we don't. They should be connected directly to the standard and standard error, right? Or did we forget to connect them? These just, okay. Here's the riders. Oh, we need to connect these. What the hell? So you will connect the destination to standard out. There we go. And then I don't think we really need to do anything else. We don't really need to forward that because that's gonna get pushed through anyway. So I don't think we actually need this. But let's see if we can do it anyway. Hello Penguin, welcome back. No? Okay, well, maybe we do need this anyway. Because if the source, if the destination is plugged in, therefore now the source needs to be plugged in as well in order for us to be able to forward it. But as long as the destination is plugged in, we should also, it should also stream it out, whatever is written into here. But okay, so but then the source should be plugged in, the destination should be plugged in, so it should forward it. I'm not sure why it doesn't do it. Do it. Oh, we have buffers here. What the hell? Okay, well, let's just not have buffers. And there we go. Why have buffers when you don't need it? Okay, well, it's not... Okay, it doesn't work anyway, okay. Okay, well, let's try and forward these anyway then. So let's do standard out. Stream. Forward. Alright, Penguin. Okay. Oh yeah, so we don't care about it. Well, we might care actually. Let's just stand it out to... I mean, if standard out closes, we can just... I guess... I don't know. I guess we'll just keep on going. Okay, now we get general protection fault. Self.source. Interesting. Okay, so something is going on, of course. Let's add a little. Should we add like a label here? So you're able to kind of label the streams, and when we output information we can see which one is which. General protection, no address available. Run function. Right, it's this stream here, so on standard out inherit. Self.source 349. It's this one, and the inherited one is over here. So this one just tries to get all these things. Wait, when we pop a forward context, what exactly is happening? Nothing. Okay. So that answers the question of if this messes up anything. So it doesn't really. Hello, Lumpy Wizard. Welcome. You're also making languages? Or a language? Awesome. What kind of language are you making? Okay. I want to add this just to have more debugging here. So let's add a label when you initialize a stream, we also add a well. I guess we could have like a format function as well. Let's yeah, because the only streams we're interested in right now is going to be the reader writer stream anyway. So I'll just put the thing here. All right. Actually, let's just put it over here. PENG. Can I show example what I think should curry be like in my language? Your thoughts if that's good or bad choice? Sure, go ahead. I love curry. All right. Let me put the thing here. Yeah, currently conceptual. All right, cool. I've got some Haskell syntax. All right, so val, interesting word there. Is that like a constant binding? I guess this also means that. Okay, so basically here's a function takes one integer, returns an integer, and here's the definition. Okay, cool. Oh, I see you have like expression, like a block, and then you have like the expression in the block. Is it like the last expression is the actual value, or hang on 1 second here. Sorry about that. Let's see the last expression. Okay. Expression block. The statement expression is statement separated by semicolon. Last expression is optional. Okay, so there will be semantic differences between this and this. I mean, yeah, I'm not personally a fan of that, but you do you. I'm just gonna say it. But well, I've said it before on stream, so and I've deliberately tried to make my language not have that. It's probably gonna have like a return function. I can understand why maybe you want to have it, but I don't know. To me, it's like could be kind of confusing sometimes. But I mean, if you know the language, it's probably not confusing. But yeah. You can do explicit return anyway. Oh, okay. Chained arrows, right? So here's like a function that takes 2 arguments. So okay. So then this is the definition. And then 3 perhaps, yes. And then some things in here. Alright, cool. And then here's like get random. Okay, so I guess a function takes no arguments, returns an int 32. Alright. And then here's a higher order. It takes a function, goes from A to B, and then a bunch of and a list from A, and then returns the result is list from B. Yeah, it's very Haskell. I mean, yeah, the syntax is like exactly like Haskell. Except I don't remember. No, the generics where they use like space, I think, yeah. Okay, and then you get match. Cool. Yeah. So does currying actually work? Where do you... F of head. Oh yeah, but that only takes 1. Yeah, conceptual. Yeah. Yeah, I mean, it just looks like a normal standard like currying thing. And do you plan to have like partial application as well? I mean, I think it looks good. The only thing is like it feels like there's like a lot of repetition. Like you do this, and then you have to spell it out again. If approved, I will work on it. Oh, okay. Cool. Yeah, I would like to do some like currying, but it feels that it adds a little bit of complexity right now that I don't need. Yes, you can partial application. Okay, cool. I mean, I guess it wouldn't be that bad, although the type thing might be... No, maybe not. Awesome. Yeah. Good job. Good work. Good job. Let's see if we can get this label in here. Label. Also, let's just do this. Oh, but now we need to... Sure. No. God damn it. Okay, you know what? Let's not do it then. It's probably gonna be constant anyway, so let's, yeah. Forget about it. This is on the to-do list. Alright, cool. I know you're probably gonna end up with I mean, yeah, theoretically then it would be like a bunch of binary, or just you know, one argument functions that return another function that takes one argument that returns another function that takes argument, you know. Something like that, maybe. Alright, so now you want a rider. Or I mean a label. So let's add a label here. Sorry, also I missed your thing there, Lamp Wizard. Sorry, my language is able to be general purpose programming language. Oh, cool. It's interpreted right now. The prototype will eventually be self-hosted. Yeah, awesome. What kind of language is it? Like, what is it? Functional, declarative, or procedural, logic based, rule based, stack based, array based? I feel like my language is kind of like, well, it's very streamy. Stream based. Pipe based. It's pipe based, yeah. Right, so now we put that over here. There we go. I should force it to be comp time or something. No, maybe not. Run script. Actually, no. Wait. Actually, no. Expected 2 arguments from one. Okay. Yeah. So this is like the standard out, and this is. I gotta denote it with double or triple. There we go. Okay, but we don't really have any logs yet for them. So this is not really used right now, so but I guess we could do it here. We could say, do we have logging here? No, we don't. Hello, Neurosite. Whoa. Welcome. Raid and run. Have a good save. Hey, thank you, Christoph. Welcome. I'm also like probably at the end of my stream here. We'll see how much time I can have. But yeah, we are currently trying to stream some pipes. Hello, what editor is this? This is Neovim. Okay, you know what? Let's do some logs here. I need to do some log debugging here. So this would be like init. Well, let's do the usual stuff, and then we have a label. Surprised you're not using that editor that's written in Zig. What's that called? Is it Flow. Wait a minute. Wait, wasn't it was it you Neurosite who worked on that, or who was working on that? Bun runtime is written in Zig, Dino runtime in Rust. What the hell? Bun runtime is written in Zig. Z in Rust. Flow is written in Zig, Z is in Rust. Okay. Yeah, I mean, I'm probably not gonna change editor ever again. I don't know. We'll see. But okay. How mature would you say it is, Neurosite? Okay. So we have a Rust Zig relationship. Yeah. Well, I don't have any Rust experience, unfortunately. Flow as a Vim-like in Zig is good enough for major Zig programmers who already be daily driving it. Would you like, what kind of advantages would you get? Can you script in Zig? Because that would be kind of cool. Right. So this would be like a binding. And evaluate back. Actually, we could just use the function name. Flow is fast, and yes, you can extend it in Zig. Wow, awesome. That actually sounds really cool. Yeah, Flow is. I think there's probably more things called Flow as well. Like Flow has existed for a while with this Facebook's kind of TypeScript knockoff. Flow browser. Write plugins as okay, well, we don't really have much logging going on. For streams. Hang on. Is it okay? Let's do like standard out. Okay, this now gets initialized. I guess we could try and add a log here to see what the contents is. String 351 forward. So let's just do like yeah, let's do this. Create a stream. now it's messed up now. Okay. Zim. Okay, well, okay. What about, does it have like Vim bindings? It has functional elements. Error handling is done via result, type, and method chaining. Okay, cool. Do you have a name for it? Is it available on GitHub or something? Okay, now we get an error here, of course, because we're trying to access label now. Okay. So let's not do that. Alright, now we should get the log. Just before. Okay, there we go. It's undefined. I mean, yeah. Okay, this is like the previous stand. Okay, that's good. Where's the label though? And why is this undefined? Struct inheritance MRO. What is MRO? Flow is very multimodal, has Vim, Helix, Emacs, and VS Code bindings. Holy crap. Would it be possible to cover entire Vim key map? I mean, okay, how much of Vim does it support? Because I need my Vim stuff. Okay, let's just log here. What do we have, like the initialize? I mean, actually, the writers and stuff, they should be called as well. They should get called. Next. Next is probably not gonna get called. No. New ref. Alright, let's do that as well. Connect destination. and connect source. Okay. MRO's method resolution order. All right. Is that some functional stuff? I don't recognize that. I guess we could add like, well, yeah, this should be standard out. Okay, it's connection, connect destination. That's it. It's just connecting destination. Okay. And then nothing happens there. I don't understand. Well, it has to be something with the... there we connect the source. It has to be something with evaluate, or when building this thing here. Okay, well, let's go to interpreter scope then. There should be like an open source project that adds all the Vim bindings, and then you import it into your editor code and implement the interface, and there you go. Now you have Vim bindings. Keybind coverage depends on the number of people using mode, how much keybinds are actually using mode. Try to add every keybind friend. Okay, yeah. Yeah, that's fair. So basically, okay, so let's check this. Let's go to here, and when we get the inherited here, I want to check if we have it. And then we're gonna log that out. Let's also log out the standard error. Okay, so apparently there it's good. What? Hang on. Oh, or no? Wait, it might be this. It might be this. Oh, it might be this one that gets fucked up. Okay. Yeah. Okay. So stand it out. So this is the pipe thing. I'm just gonna say that, and then stand it out. Inherit is gonna be inherit pipe stream. Oh my god, this plugin is messing me up as well. Okay. Okay, no more errors. Oh, hey, Lumpy Wizard. It has functional elements. Error handling is done with a result type method. Oh, yeah, so. But what? How would you describe MRO? Like, is that just a way to like? Is the entire language like one expression, or how does it work? Or one's, I mean, one, like, I guess one program, is that just one expression? Okay, so now we don't have these issues anymore. Great. Let's. Oh, but now we have all these goddamn debug logs everywhere. But actually, I just learned this little trick that you can have some kind of config somewhere. Is it zig config or what is it? No. Is it process? Oops. It's built in. I mean, it was basically a way to, yeah, options. Set, like, like the log function. You can like set the log function to be something else. Log enabled. Determine if specific. How do you set it? Since the scope login names with logs are. Oh. Okay, I never looked at these things. So, okay, what scoped returns a scoped logging namespace. How do you like change this? Overridden by the root file. Okay, whatever. Okay, so we're back to square whatever, where this file doesn't output anything. I want to see what this parses into. Print AST. So it's just a call, and this won't output anything. But yeah, because we're not reading from the out. But in theory, this would, because now this is a pipeline, and a pipeline is set up in a different way. So now we're trying to go through each segment of the pipeline and kind of forward the things through. Although maybe we are missing like the last one. Okay, let's try this. Let's go back to here. But that's what we're trying to do here. We're trying to forward the last thing as well. Alright. Basically, my programming language supports overloading, which means you have to choose the best matching function for the arguments label. Oh, I see, I see. Usually it's done by name angling or add a type information in a simple table with your method name, but my language supports optional arguments of variadic types, so it's hard to do name angling. Instead, what I have implemented is a score-based system that selects the best match for the given arguments. Wow. That sounds really cool. So okay, but do you find it could it potentially be hard to like reason about which operator or which function overload is gonna get called? Or is that like, does that feel like natural when you're actually like writing the code or looking at it? Yeah, so here we're forwarding everything there, and then we're forwarding also the last one, I think. So I guess now we'll enable the streams again. Let's also have like this thing there, because then we can actually say the function name, And I guess we'll have like a label here. That's the label. Oh shit, but now we need, okay. Is there a way to log without an end line? I guess it doesn't matter that much. We can just do this. Yeah, let's just do, this would be self and then label and then format. Oh, 1 second. All right, this is reader writer stream. And right, so let's get the parent. Wait, what? Oh, I see. This is the try. Okay, okay. Yeah. Mute. All right. Now we got a whole bunch of things going on here. We can see which stream is doing what. Let's see. It should be natural. Try to design it intuitively so at times follows except typing. Less tightly inherit the typing less close for any type, varying parameters. So you should theoretically be able to predict what functions should be called. A little less obvious instruct method calls for multiple inheritance, which just uses breadth for search and uses the first result match. Oh. Yeah, that sounds could be interesting. Real nice job. Also, I didn't see if you had like a language or a name for it or or like a GitHub or something. Okay, so what's going on here? Standard out, standard do. Should we also say like which ones they are connected to or something? Because we have that as well. I mean, that's the writers and readers. I guess we don't really have that. Chestnut. Okay, cool. Thank you. All right. Awesome. Is it I was gonna say if it was indentation based, but I can see maybe not. Oh yeah, it was interpreted right. But it's gonna be compiled, you said. Cool. Null coalescing. C is equal to 10. Let's see. Use A over B. Ah, cool. That's interesting. I think that's the first time I've seen. Oops. That was the wrong window. Where is it? There one. This, like, using words to handle, like, yeah, operators on like optionals. It's going to be compiled. Changing over from LOVMIR to C. This is to support primitives up to int 1024. What the hell? What kind of calculations are you gonna do? What editor is this? This is NeoVim. Forward. So we are forwarding here, yes, a little bit, and then the initialize. So we are calling forward like 2 times. But do we have any bytes? Let's see if we have any, if we get anything. Yeah, bytes forwarded. God damn it. Zero. Okay. 6. That sounds correct. 6 bytes, right? Hello. I mean, this is 5, but then you have the new line at the end. Okay. Alright, so this guy is forwarding 6 bytes. Let's do this. Let's go to the main function thing, and let's also log out the these pointers here to these writers and this writer and reader. So now this is, well, okay, this is no longer, well, okay, let's not do it like this. Standard out goes into this writer. Standard goes into that. And I also want to go in here and change the log function to say if have a source, then if we have a destination, we will log source into destination. Yeah, sure, let's do that. By the way, do any of you know a better pattern here when you have multiple optionals? All right, standard out is this guy, not referenced anywhere. Yeah, I know I can do this, and I have to have like a thing there. But it's still... Now it looks like a manual bind operation. For those of you familiar with functional, with monads. No, because you can capture it at the same time. Chaining is fine. Yeah, but it just takes up so much... I wish you could do something like, you know, like in for loops, when you have multiple sources, and you can do something like this, like destination, source, destination. And I know that I've actually read something about this explicitly not being supported for some reason. But yeah, anyway. Because it would be consistent with the for loops, right? Kinda. All right. You would need to make sure they are both capturable, so it's really an and check. Yes, but I mean, yeah, I was just thinking, like, if you have this, it's kind of consistent with the for loop, and I don't know. You could say it's an and, but really, since you're capturing both of them, it's kind of implied. That was what I was thinking there. And of course, I've tried to do this, which also, this might be better actually, because of the thing with the Boolean refactoring, which you oftentimes have, like if you have, like, let's say this was a bool, and then you don't have a capture, and now we refactor it into an optional instead. So now you start to capture the data. But let's say you had two bools, self, destination. You have two bools and you refactor them both into optionals. So now this would be the refactor. You're really kind of keeping the same pattern there. So you don't have to, like, if you can use, it's kind of like optionals and booleans are kind of, they are kind of related in that sense. It feels like almost. Yeah, I did read an issue where someone did suggest this, but it got turned down. You could use tuples destructuring, but that would require wrapping into. Yeah, I don't want to have to do that. Okay, thank you. What did I want to do? So I want to see when we connect something, what do we connect to? That's what I want to see. Connect source, and then it's like connecting, so then connect to this, and then here same thing. All right, so standard out connected to destination this. So this is the actual standard out, yeah. Okay, standard error is connected to this. Okay. Which then is apparently used over here. Why does standard error get like more action here? Connect source standard error. Standard out, standard out, standard out, standard out, standard out. No. Okay, there might be something wrong with this setup here. I'm just gonna double check what's happening. I'll just BRB 1 second here. Also, how many of you are like familiar with the async stuff? Is that gonna change a lot of how the I/O works in 0.15? Because I'm using 0.15 now, and I'm, you know, basically this whole program is all I/O. It's gonna be interesting to see how much will be rewritten. The I/O won't change. Okay, that's good to know. Well, that's good. Great.
Okay, so what is happening here? First we have the standard out, standard much. Standard eye writers already new interface. Yeah, I know. I was just thinking that it might change again. that was my fear. A little bit. All right, so we got standard out, standard there, connecting to the actual standard out here, and then you connected this one, and then we got some kind of pipeline thing. We only got one of those, which connects to some kind of source. That should be the standard out of the... Okay, let's log that out as well. So standard in... Let's just use this one. Oh, that's the file. Right, oh, here's the writer, right. Standard in writer, there we go. That's the file writer, so we need the interface. And then the child is called argv0. And use the stable child. And this is standard out. Standard all right. Okay. Echo standard out is connected to the source of this one, and standard is connected here, and of course nothing gets forwarded. Good. What about this one? We forward 6 bytes, but they don't seem to go anywhere, because then this would log out that it was like connected somewhere. It has a source, but it doesn't have a destination. Why? Oh, it's this pipeline here. Okay. Why do you not have a destination? Wait. Okay, so we should actually have one read-writer stream, because we have two stages, so it's just one stream between them. And then the standard out and the last item is like inherited. So that should be this pipe right here. And when that gets inherited, and then okay, let's enable executor. It is forwarding. So we have the thing here. Yeah, that's the child connected to the source of this. But where is this? Where's the destination here? We don't have a destination. It doesn't connect to a destination. Okay, let's go back to pipeline. And so we create a stream over here, which is supposed to take standard out and put it into standard in. And then this should be connected to the standard out of the outer scope. But for some reason this pipe is not connected to the destination. So we have one thing. This goes through all the stages. So when we're at the first stage, it's over here. Index is 0, I is 1 because we're going backwards. Wait, or is it the other way around? Oh my god. It's the other way around. Index is the actual index of the thing. I is from 0. Okay, I actually thought the other way around. Okay. So I is 0. So standard in should be blocked. No. In no, I is 0 over here. Okay. So I was thinking correctly. I think. Index is 0. So then this is blocked. Yes. And then Otherwise, it's gonna take the previous thing and connect standard in. So that seems to not work actually. Because we never get to... Yes, we do. We get to I equals 1, which should set this standard. It should connect that to there. Okay, so the standard in is connected, let's say. Was that the thing actually? Was the standard in connected or the other one? Standard, yeah, standard in was connected to standard out. Of the child, wait, no. Oh my god. No, it wasn't. Standard in is not even defined here. Okay, so standard in is never connected. Okay. And then, okay, but standard out is... We inherit, and next one we actually take the index and connect it. So this one seems to work, but this one doesn't for some reason. It should exist. Like, why doesn't it exist? For the first one it doesn't, but for the second one it should exist. Child echo. Oh, we never see child spawn actually. Or child cat. Cat is not even spawned. What the hell? Wait a minute. It's not even a... Are we never calling this or what? No, we are transforming it into a... I'm pretty sure we're transforming it. Yeah, we're transforming it into a function. Oh, it should be a function call, I think. Hang on. Yeah. Okay. So we're making the function, we're making the executable. We also have to make the call. No, but that's the value. Okay, god damn it. Okay.
we need a call. The callee is the identifier, and then we have this well, we don't have an argument, but if we only have one identifier, we need to make it into a call if it's not found. Yes. So we have to create a call expression. It's going to be an expression which is going to be a call arguments empty span and the callee is an expression which is the identifier. So that's just the identifier, except we need to like create an actual expression. Okay, well, let's just create an expression now. So this is the callee expression. Create and then yeah, we don't need to keep it around, so I'm just gonna destroy it. Okay, and then we have the call expression. Now you are the callee. Okay, so now we can populate you with identifier equals identifier and span equals span. Okay. Right. So now we have the call expression, and now we can say return self-evaluate expression call expression. Don't feel that. Oh yeah. Okay. Well, we don't really see it in the AST, which is kind of bad. Like, we should actually do this like in the AST. If we just encounter an identifier like this, we should probably like do a call. But the thing is, like, right now we don't have the semantics to know if this is supposed to be an executable or a function or a variable, so we don't know if we can call it or not. So, but anyway. And we get a segfault. Okay. I'll just disable the env map thing. Where is that? Interval scope, env map. Where is this thing happening? Where is that happening? Where is that happening? Holy crap. Okay, now we're stuck in an infinite. Okay. Because, okay, so it's trying. So if we have a call It's trying to allocate. Okay. Well, maybe we can declare it then. But wasn't that what we did here? Maybe. No, not that one. We get a declaration. We should actually like declare it. So next time we just call it instead. Okay. So function declaration. Alright, now we have a function declaration of that. And then we will declare it in the scope. Maybe we even create a subscope. Nah. Since it didn't exist, so we could just declare it in the current scope. And then we have a value. Of course. Oh yeah, that's right. We need to do like this. Thank you, Piano. Have a nice day yourself. So I'm creating this value. It's a function which refers to so it's a function reference basically. So we're referring to some kind of function declaration here that we create here as well. We don't have a closure. We're using this arena thing for that. And then we declare it so we don't like. Actually, we could just return it. No, but we need a call expression as well. Yeah. And then we declare it. And the value is going to be function declaration value. Okay. And then we also create the call expression that actually calls the thing, and we evaluate that and return the thing. Okay, so we don't need that. There we go. Unsupported callee. What? The callee expression is. Oh, I see. So this is actually the function. But now we need this. Okay, well, let's just grab this. Wait, but then the callee, why do we need the value?
Okay, so now we get unsupported calling and what the hell? Wait. Evaluator, yes. It has to be a function ref. I'm confused. It's an expression. That's a value. Oh. Oh, okay. So we do need to declare it, I think. Or do we? What the hell, man? Like, how does this work? Like, we have the identifier. This evaluates into the function, right? Then we already have the function. Okay. It's like when we okay. So this should evaluate to a function ref. Which, if we declare it first with the identifier name, but then why wouldn't this work? This should work then. We could provide an identifier that should why wouldn't this work? We declare it, it should exist in the scope. When this gets evaluated, it exists in the scope. This identifier should evaluate to a function ref, which should be what we need. I do not understand. Value pipeline, value expression, value call expression. Alright, so let's do this. When we evaluate a call expression, we want to log value span of the call. So now we can see exactly which call we're trying to do. Or not. Oh, it's because of the error. Okay. Okay, well, let's extend this a little bit.
Okay, so it's this call that gets unsupported calling now. But why? Wait. Okay. So it's because like when the callee, like okay, evaluate call. There's like a recursive issue here. Like when the callee gets evaluated, it gets evaluated as an identifier, which it's like a recursive loop. Except it should be defined at that point in that case. Like it should be defined, but maybe. Okay, so this actually this depends on which context. Now I see what's going on. So basically the first call now fails because this is it's evaluated into a call. Maybe we can. No, god damn it. It's because of the I mean, okay, what we could do is like say, hey, if you only have an identifier and you don't have arguments and we don't find it, well then it's a, you know, then we call it as an expression. But if we when we're parsing, right? So when we're parsing this is obviously a call here, but this should also be a call. So we're calling this, but in the calling evaluator, it would look at this, and if it, for example, if it was another thing, it's like a string here, and you just say s, and we call s, that basically says that the evaluate call expression has to now support this thing as well, which I guess would just unwrap the value inside the call and just return that. If it's not a function. If it's not a function, we just return the value itself. If it's a function, we call it. Okay, so let's go to the parser and parse. Where are we actually? No. Yeah, it's, let's see. So it's gonna be parse expression. It's gonna be this one, and then this one. If we only have one identifier, we get the thing itself, which is just gonna be an identifier. So should we then, in this case, like if we only get an identifier, no, because this is called recursively, so that doesn't work. Actually, it does work. We should wrap everything. Yeah. All lonely identifiers should just be calls. So actually we could put it here. We could put like to identifier, or this one should actually not be just an identifier. It should be a call.
to the identifier. Callee is equal to this. With no arguments. And span is just going to be identifier. Okay, so now that's a call. Good. Then we go back. Now we okay. So now we do print AST. Okay. Well, okay. Now we got the S thing as well. But I guess we could look at that as well. So the S binding here. Yes, we got a call now to the identifier. You don't do some weird double calling here, and you're a call. Okay, good. Now everything is uniform, and we go back here. Now I lost myself a little bit here, but okay, so we're here. So now we shouldn't do a call. We don't do this. Actually, I'll just remove this. We do a declare. Well, actually, we don't need to do a declare. Now we can just return the identifier as an yeah. We just do as we did before, actually. So we could just remove this whole thing. I'm gonna remove you as well. We're gonna do the original thing here, which was to return a function reference to a new function declaration here. Okay, we don't need to declare it or anything. I don't think so. Now, all we need to do in the, because now we're gonna get unsupported whatever expression here. And leak memory. Yeah, unsupported callee. And so we go over to evaluate call expression. This the leaks may very well be just something error happening in here. What's happening here? Why is this not like deinitialized? Oh, it is in the defer here. Okay. But this one is not. This is not deinitialized. Is that the error? Yes. Okay, good. Now what? No. Okay, now we got this unsupported callee. I'm gonna remove the logs for the scopes and everything, or the streams. Okay. Now we need to support, like, if it's anything else than a call, than a function ref, I'm just gonna return the value as it is. Return, oops, callee. Actually, this should get the initialized. This should be a defer. Yeah. I'm pretty sure. Okay. That is good news.
We finally get anything to the screen, something to the screen. I mean, yeah, in this, okay, but it's blocking. Okay, so so basically what you're seeing here is that this S gets like turned into a stream, and then it's forwarded out to the outermost context. But when it's done, it doesn't close, I guess, itself. I'm gonna do this for now and test this first. Okay, still nothing. That is disappointing. Okay, let's go back here. Let's re-enable the logging and see where we end up. Okay. So, do we get a child called cat? Still no child called cat. Why? Let's enable runic log executor, and let's do like evaluate call. What is happening here? Get nmap, declare mr. Oh, declare mr. Okay. God damn it! I wish that we could like change this to not output anything during this, but okay. So I think, yeah, but this is the like the first thing that happens, like run statement. Yeah, we do this evaluate pipeline thing. We're setting up the stuff. Now here's we're evaluating this thing first, which should connect it. Like we're executing a function, sets up a bunch of stuff. Wait, why do we have like 3 forward contexts here? Oh, that's the closure. Wait a minute. The forward contexts, we shouldn't have those in the closure, right? Does that even make sense? Or wait, no, we do. No, wait, we don't. It does not make sense to, let's say you want to define a function, closure, I mean, yeah, for example, in the module here. So, but I mean, let's even say this. Let's say we have a function, hello, and you import this. Now, what am I trying to say? Yeah, we import this. But the context, like whenever you have a function declaration, like the standard out, standard error, that is not known yet. So we shouldn't care about what the context is when we declare a function. It should just be when you call a function. That's when you care about the forwarding context.
After 6 to 7 plus hours of my setup, Tailwind React setup is finally working. No pun intended. Wow. Congratulations. Is it your first Tailwind React setup? Yeah, okay. So yeah, it doesn't make sense to pushing the forward context into the thing. Also, current working directory. It doesn't make sense either. No. So this should be like the forward context. This doesn't make sense to have either. It's only the bindings, really. The bindings and the blocking. Yeah. Binding related stuff we have. Oh, except this is a whole ref here, though. It's a whole goddamn ref here. But we could just ignore the forwarding. How would that work, actually? I mean, we barely even use these anyway, so whatever. No, still same shit. Setup is the harder part of the program. I mean, yeah. I guess if it's your first time, I get it. It took me a while to understand like the whole setup thing with Tailwind and that whole thing. Although it's like, yeah, I don't know. What kind of are you using Vite, or did you use any kind of scaffolding script, or what? How did you do it? Did you just do a bare like npm or bun init, or how did you do it? Or maybe you should try to talk about it now, or you don't remember. Okay, so that's no longer in the closure. Okay, so let's see what else we've got here. All right, here's the pipeline. So because we're pushing processes here, and Vite. And that is I mean, yeah, because it's supposed to be very simple to set up. But I think what you could end up doing is maybe using some kind of outdated scaffolding or something, because I mean, there's so much history there by this point, so I don't know. But it's always like every time you want to do a new project, it's always the same thing. You always have to go around and look at this latest things. Everything's changing all the time. Okay, so now this closure pushes a single frame, so that's the only thing we have. Closure from that, yeah. Alright, you do that. Thanks. Good luck, you too. Man, we're so fucking close now. Okay. So that's the initialize, that's fine. Where is the forwarding context actually? There should be a forwarding, no, that's the closure, right? That's the closure. Yeah, okay, that's fine. But wait a minute. Where's the call? It's just a function declaration. Wait, there should be a call here. Yeah, there's a call. Wait, there's a function declaration and then a call. What the hell? Okay, there's the issue. I didn't see that before. Okay. Evaluate. No, parser. Wait. No. Evaluate. Whoops. Wait, hang on. How come there's a function declaration? Around the call. Oh, wait. So when you, okay, when we do the pipe thing, it makes a function declaration. I see. That we then don't really call. Okay. Where is that pipe at? Where's the pipe? Here is the pipe. Oh yeah. I think we have a special case for pipes somewhere. Here it is. Here's the culprit. Yeah, okay. The idea was that when you have a pipeline, like the expressions that are between, like that are like after the first one, was turned into a declaration that accepted like a standard into it, which makes sense from like a type standpoint. But now we can just use the call. We don't really need this function declarations anymore. It was just a way to kind of think about how to evaluate this whole thing. But now we don't really need that. So I can, yeah, we'll just remove this. And you will just be the right. Okay, so if we do this now we just have a call here. Good. And does it work? Of course it doesn't. Okay. Well, what's happening here? So now we get a whole bunch more stuff happening here. Cat. Now we get cat. Great. We get cat. Stand it out. Becomes a reader connecting to this, which is standard out. Okay, great. So we're connecting this reader to the reader of this standard out. And then you should be forwarding this. Reached unreachable code. Rebase. Limit. Oh man.
Okay, so it went through a few of these. We got the echo standard out here. All right, now you're connected to this pipeline thing. And we're forwarding. So now this is fully connected into this rider, which is, which one? It's the cat standard in. Great. But it doesn't seem to, nothing seems to happen. Byte forward is also always 0. Okay, so, and then we also forward to standard out, but there's nothing happening. Oh yeah, so this guy is not forwarding anything because it's not connected properly, I think. That's the cat standard in. That's destination, but it needs the source as well. Now, hang on. This. Yeah, this is connected standard in, connected source, yes. Okay. And now we have echo, which standard out connects to this guy. Great. So now this is fully connected. And we forward that, then we read from standard out of echo and try to forward it but there's like 0 bytes. There was 6 bytes before. Why is it 0 now? Okay. And then we have this pipe as well. This one is from, yeah, this is the standard out. So this reads from this thing, which is the cat out. And it writes to standard out. Yeah. But nothing gets forwarded. And why is that? And then there's an error. And why is that? Maybe it's because the thing has closed or something. I don't know. Oh, god damn it. Okay. Evaluate pipeline. Man, there's been so many ups and downs in this. Well, mostly downs. But I think we're... It depends on how you look at it. If it's an uphill battle, it has been an uphill battle for a while now, but hopefully this will get solved here soon. Okay. This seems correct now. The connections seem to work. Or they seem to be properly set up. And the inherited streams are forwarded here. Where was the error happening? One of these. Reached unreachable code. Buffer length minus preserve.
minimum length. Rebase. It's trying to do a rebase for some reason. You know what? Let's do. Actually, we have one thing that we didn't do. Connect destination. This actually writes everything from the current allocating buffer. So basically, how these streams work is they have a reader and a writer. The reader is connected. When both of them are connected, they can be optional here. Well, they're supposed to be connected, so you're connecting both the source and resource. But basically, while you're trying to connect stuff, this can get written into, and this writer will write into the buffer writer as a default. However, once the destination has been set, it now empties all of the things in the buffer writer to destination, and also now this is rerouted to the destination. So it's kind of like a rerouting. First it has a buffer that it writes to, but then we reroute into destination once it has been set. And also the source is really only you can set the source and then call forward, which will read from the source and or stream from the source into the writer. But really you should be able to write to this at any point once it's been initialized. And the buffer is empty, so it's always gonna drain everything to the destination. Oh yeah, thank you Lamp Wizard and Noon Malay for following. So I'm a bit slow on the announcements there. Okay, well, because what I was thinking of doing now is that when we connect, we should also say, okay, well, how much did we write to the thing? So I'm gonna grab this bytes written from buffer, or I guess this would be the buffered and then we can log bytes forwarded, which will be buffer.length. I'll do it, I guess I'll do it down here. So now we can see, like, when it connects, it's connected here, bytes forward at 0, bytes forward at 0, 0. Okay, so we didn't get anything from that. I mean, okay, maybe the issue is that when it tries to do the unlimited, there's something wrong with something somewhere. And you get a bunch of garbage. I mean, I don't know. Maybe it feels like some kind of pointer issue, but it seems to work fine until all of a sudden it doesn't. Okay, so what is going on? Let's go to the loop here. So every time we forward, we get the source and the destination. We try to do stream. Now, this stream is a built-in function which will read. Well, it would use, I guess it uses the buffer firsthand, but we don't have a buffer, so it's always gonna take the thing. Maybe that's the issue, actually. We don't have a buffer. No, but when it writes, the echo writes into a writer that either is oh, but that's the thing. We don't have a buffer in the reader or writers, so there's nothing, so we can't store it anywhere. I think that is the issue, yeah. So, okay. Okay. Now, okay, so it kind of means that when this tries to stream whatever has been written from this, like the reader can't store anything. Or can it? No, because the file reader doesn't have any buffer. Yeah, that's the issue. The file reader doesn't have a buffer. When the process tries to read into the file reader, I guess it just disappears because it doesn't have any buffer. I wonder if you can have like an allocating reader or something. No, you need an allocating writer in that case. I don't really understand how the built-in file thing works, but so basically here, where is that stuff happening? Well, no, spawn process. Yeah. Now this one. So this reader has no buffer. So when the process is streaming into the, but how did we get 6 bytes before then? I don't know. But when this writes into this file, but shouldn't there be some kind of innate buffer? I don't know. Let's just try adding something here. Okay, yeah, and then we can use the allocating, yeah, we can use standard out buffer. It's gonna be the scopes allocate. Now we can use this one. Perfect. Or can we actually? Because this is gonna get... No, I know what's happening. No, I don't actually. Sorry. I'm just joking. Okay, so this will be... no, this will be U8. Yeah. And the size, I don't know. 1,000 bytes. All right, that's the buffer. Let's put it in here. Does that solve the issue? No. I mean, it might solve one issue, but it certainly still crashes. Oh, and we don't get like anything forwarded either. Yeah. I mean, okay, well, let's do the same for standard error, I guess. No. What about standard in? No, if we add things, the writers, I don't think the writers need buffering. It's just gonna drain into standard out. No, I mean standard in. So that's fine. We don't really need a buffer on that one. I don't think so. Like if we add a writer on standard in, we need to flush it now. The thing that I was thinking of, if this file reader got like popped, but I don't think it does because the context push allocating is happening in the pipeline and not nowhere else. So this happens in the pipeline. When we then evaluate this expression, which calls the execute response to process, it will use that to do it, and then that gets popped down here. So that's not gonna be an issue, I don't think. Man, I just really want this to work right now. I don't want to end the stream before fixing this issue. It just feels like we're so close. So it's the writer that fails here. The writer fails. I mean, you would think if you run out of buffer and you need a buffer, then it would get some kind of other kind of error. Yeah, if we introduce a buffer here, it's gonna like, we have to flush it now. That's the issue. I mean, maybe it's not an issue anyway, because if we need to flush it, then we just flush it, right? Okay, fine. If we do this, will this do anything? I'm very skeptical, yeah. Okay, well, okay. We actually do forward something here. No. But then we still get some error here. We still get like the same error. And we don't see anything on standard out. It like takes a couple of loops before it starts to forward the thing, which is kind of interesting to me. Forward, so we call forward and we try to, maybe it's closed, but
is it closed or? Like we are checking here, like stream. If we have an end of stream, we return true, which indicates the stream has ended. Okay. I'm not sure what more I need to do there. I guess the reader could also be closed, maybe. But that doesn't make any sense. Or I mean the writer. The reader should be the one that closes first, and then this is just the end of the stream, and we close everything. Maybe it's like the order of operations. Let's see. Okay, let's think about this one more time. Let's go to evaluate pipeline and see. Here we're going from left to right, except the index is going from right to left. Okay. And these are. This is just a list. Okay. The reader writer streams. But we're saying index, which is referring to the actual index in the pipeline. So at first it would be the end, and then we go like from right to left. While I refers to, of course, the 0 from left to right. So index is from right to left, I is left to right. Doesn't even matter. I mean, we're just setting everything. And anyway. Okay, but then it's like, okay, well over here, we're going from, I guess, I would be from left to right. Should we do other way around? No, it feels like we should do from left to right. Maybe there's something wrong over here. If we're not closed, we do that. We go through everything. If one of them is not closed, we continue. If everyone is closed, we break. And then we wait and stuff, but we never get here. And you're a pointer. Okay, let's do what we have neglected. What I've neglected to do here is actually go in and check what's happening in here. So what's happening is we call stream. All right. This calls vtable stream, of course. Makes sense. Well, vtable stream is gonna be the file stream. Wait. Yeah, that's the only thing we have. We only have file streams actually, or file readers. So actually this is gonna be like reader, no file, reader. where is it? Here. And then okay, so it's this thing. Yeah, file 1330. Right. Streaming reading. I mean, maybe we should not use streaming. I don't know. Avoid syscalls other than read and read. Okay. There were some comments about it somewhere. Positional is more thread safe since the global sync position is not affected, but when syscalls are not available, preemptively initializing in streaming mode skips a failed syscall. Okay, so are you saying that you should always, like, it's better to use the positional? No, wait, there was like reader streaming. Right, here we go. Position was same thing. Defaults to positional reading, falls back to streaming. Positional is more thread safe since the global sync position is not affected. Okay, well let's just forget about the streaming thing. Let's just see if it works with the other way. Yeah, although it feels very, you know, it feels a little bit iffy. If this would fix the issue, I don't know. So where is this happening? It's spawn process. All right, let's just do writer, reader, reader. And same thing over here. Also, now it failed even before forwarding anything. Okay, let's go back to the thing. IO writer. So IO writer is where it like fails actually. Writable slice greedy. Asserts the provided buffer has total capacity enough for minimum length. Really? So, and we can also see it's only requiring one. So maybe we actually do need a buffer. But again,
flash. Let's just see if this does anything. So we need to do that. And you. Okay. That seemed to have solved the issue. Okay. Oh my god. Okay. Now it seems that nothing like it gets stuck there. So good. Well, okay, we need to solve a couple of issues then. So evaluate pipeline again. So when we forward, should we just flush? I think we flush if the destination is not our buffer, maybe. Oops. I wonder if we could check that somehow, like. Okay, we got ourselves a little hello here. Holy crap. Whoops. Okay. Yes. Okay. Now, where do we get stuck? Where are we? Child spawn process. Wait, do we not go out of that or what? I mean, we are able to spawn both processes and they forward through, so we should be forwarding the things? Question mark? Yeah. yeah, this is spawning the thing. So that, right, so we already spawned a cat. That cat gets spawned first. Spawn process. Very well, very good. This all gets spawned. And then the next thing, it gets spawned. And then we pop some frames, apparently. Oh, that's in the run function. Evaluate pipeline pops a frame, which is the forward context. And now we're in the, now I think we're in the loop here, forwarding things. Or not this one, but this one here. We're in this loop forwarding things, and for some reason things don't close when they're done. So let's enable streaming logs again. And it does stop, so it doesn't, we stop calling forward now. Because otherwise it would just have kept on going and logged out everything. So it seems that we don't forward anything anymore. And if we go to back here, and right, so end of stream. I guess we could let's log that. Ended stream. Will it spam it now? No. So we got ended stream on this one. And this one. Standard error, ended stream from this reader here. Which reader is this? I don't know. We disabled that. Well, anyway. How many reader writers do we have? We have 2. Which both ended their stream. So why are we not, like, why is it not going out of that thing? So this should have as many items. This should have 2 items. This also has 2 items. And then we're going down here. And this doesn't seem to happen either. I think what we're doing is we're getting close. We're getting stopped here. Oh, maybe we need to wait for them in a specific order. Maybe the echo need, like the first one needs to close first. Like we need to wait the first one first and then the second one. Because this just goes through. This goes through actually in a reverse order because they are spawned in a reverse order. I'm not sure why I did that. Maybe we should just spawn them in a not reversed order. I don't know. It doesn't actually matter. Like in which order we spawn them in, actually. So it's basically because we are like reversing the thing here. That's the stage we're interested in. If we just say I here instead. Very important there. I guess we could keep the index. Well, no, actually now the index should be I. actually. It's just I. Actually, okay, that's the only thing we need to change. Whatever. Index is I. Okay. Nothing else should like need to be changed here. It's just the order. It's just the order in which index is traversing from here. So, will it work? Index out of bounds. Wait, okay, so if length is 2, which it is in this case, and then this is 1 negative, so first is 1 and then goes to 0, right? How? And then this also goes from 0 to 1, so this should have like the same domain. I mean, it's equal to I. Why? If it's more than 0, this is negative 1. If I see here. If I is 0, let's do like if this really is saying index is equal to pipeline stages length minus 1. If we are at the end, this is what this is saying. If we are at the end, we should use the inherit. Okay, no difference. But now, okay, now the processes should be like evaluated, or they should be spawned in order, and you call wait on the child. So I mean, oh yeah. No. Okay, you call wait on the frame, which has all the processes, which call wait on the child. And there's no error reports or anything. Blocks until child terminates and cleans up our resources. And I mean, the child should terminate, like all the streams are closed. So what's left? Maybe the echo got closed. Yeah, let's do this. Let's do like child closed or terminated. Okay, so it doesn't happen. Now standard in is already closed for the first one. The echo standard in is already closed. I didn't have this much trouble spawning these processes and waiting for them before. Do we even get there? Actually, we don't. Where are we? We don't even seem to get in here. Both of them ended the stream, so we should have been set to true.
And once it's set to true, this should be true, and then we never go in here again, right? It's closed. And then this doesn't really matter. And then we're looking for, I mean, maybe it's this else thing that I just don't understand how it works. So actually, let's just do like, if we get down here, we break. Yeah, it could just be that the else, I misunderstood how the else worked here. No? God damn it. What is happening? Where are we? Okay, so it's like, should we log something here? This should have ended the stream. What happens then? We don't really do anything. This should still exist. No, the source doesn't exist on the first one, that's right. No, but then we should still... No, yeah, it does exist. It does exist. Hang on. How many stream redirects do we have? We do have one only. Oh my god, yeah, that's right. I totally forgot that we only have one. Oh, wait, no. Okay, man, we are so close with this one. But yeah, I have to go now, so I have to eat something and be a human being here. But yeah, man, we are so close with this one. Okay, so yeah, thank you very much for watching. I'll see if I can send you off somewhere if you want. I'll just drop and go here. What is this? Okay, I'll just send you off somewhere. Yeah, have a nice day. I'll see you later. Bye bye.